Welcome to Introduction to Hardware and Operating Systems. According to Statista.com research, global IT spending on PCs, tablets, mobile phones, printers, data center systems, enterprise software, and communication systems is expected to total about $4.45 trillion in 2022. Who will install, configure, manage, and program these IT assets? The most recent U.S. Bureau of Labor Statistics report indicates about 667,600 annual job postings and projected job growth of 13% through 2029. At the time of this course publication, the median U.S. IT salary was $112,161, more than double the U.S. median salary of $41,950 for all jobs. An IT role is right for you if you like change and enjoy ongoing learning. Computing technology is always evolving, and there's always new technology or a new feature to learn. If you're balancing work-life commitments, many companies offer on-site work, remote work, hybrid work environments, and flexible shifts. Employers need coverage 24 hours a day and 7 days a week. IT careers offer multiple paths for career growth, and if you enjoy making a positive difference for others, an IT role can be rewarding. When you complete this course, you'll be able to describe and apply operating system fundamentals and identify, classify, and describe computing devices and peripherals, interfaces and connectors, and internal computer components. Then gain job-ready skills and certification-ready insights when you learn about recommended workstation evaluation, setup, and troubleshooting processes and practices. This course is the first in a series of IBM courses intended to help you develop IT fundamental skills and knowledge. In addition to gaining valuable skills in Introduction to Hardware and Operating Systems, this course, along with other IBM IT courses, can also aid in your preparation for the CompTIA IT Fundamentals Certification exam. Especially for beginners, guided instructional videos walk you through key concepts with essential need-to-know facts. Interactive activities reinforce what you've learned in videos. Forums provide connections where you can introduce yourself to others, provide feedback, and get support. Practice assessments help you gauge your knowledge, and graded assessments prove what you've learned, leading to a shareable badge and certificate that you can show prospective employers. We're here to support your success, and we're excited that you're here. Let's get started. Welcome to Introduction to Computing Fundamentals. After watching this video, you will be able to define what a computer is, classify computers based on their size and their uses, list the 4 functions of computing and the parts of a computer associated with those functions, and describe the benefits of computing. A computer is a device or system that includes hardware, operating system software, application software, and peripheral devices. Hardware is the platform that processes data based on the provided instructions and stores data. Software includes the operating system software that enables and configures hardware capabilities, and the application software that enables the computer to perform tasks. Peripheral devices, such as keyboards and monitors, enable user input and output. And finally, computers need users who provide instructions. A fast way to classify computers is by their size and speed. Supercomputers are the fastest computers and are used for the most complex mathematical and analytical computations. Mainframe computers function at the speed of business and are used to perform transactions and more. Next in size and speed are mini-computers, which enable more than one person to access the same data. Finally, the smallest computers are microcomputers. This category includes personal computers, laptops, smartphones, and other single-user devices. Another way to classify computers is by use. General-purpose computers perform functions such as creating documents, saving files, web conferencing, working online, financial analysis, data analytics, coding, and other multifunction capabilities. Even smartphones can be considered general-purpose computers. Special purpose computers, which perform defined limited use functions, include IoT devices, such as sensors that report water quality, lights that activate during occupancy, sensors that report building occupancy, and IoT devices that monitor manufacturing processes. Other types of computers include Wi-Fi-enabled appliances, weather stations, alarm systems, and both wired and wireless gaming consoles. Computers perform many tasks, but we can simplify and categorize those tasks into 4 easy-to-remember functions: input, processing, output, and storage. Let's learn more. Input is the function or action of getting data into the computer. Input happens when you type or tap on a keyboard, use a touchscreen, or speak a voice-to-text command. Clicking the send button for an email is also input. Input is also the information and instructions a programmer provides to perform calculations using a set of programs. Next, processing happens when the computer receives the input and then converts the data into a format or action that a user can recognize and use. Examples include downloading an app, document, or photo, and moving data from one drive to another. Processing also occurs when the computer performs programming instructions, such as data calculations or even instructions to fly a rocket to the stratosphere and back. Technically, processing happens when raw data changes into usable formats, such as email, documents, and photos. Processors, also called central processing units or CPUs, are located inside computers on a system board, also called a motherboard. These boards and their processors are usually located centrally within the devices. Next, the computer delivers the processed results to the default or configured output devices, including monitors, speakers, and printers. Output, meaning what you see, hear, or understand, is what makes the data apparent and valuable. At the same time or just after the processing function completes, and while output is happening, computers can use the storage function. Storage is the saving of data to disk space on your computer, an external hard drive, or on network or cloud storage for an indefinite or undefined time, unless you explicitly specify a data expiration date or delete the data. Storage saves data for reuse. Server, desktop, and laptop computer storage is usually located inside of the case and to the side of the case. Storage is often welded onto the system board for phones, IoT, and gaming devices. So, what are the advantages of using computers? Manual entry errors are eliminated by using capabilities such as copy and paste and data duplication to reuse data or content. Communication is sped up by using network, wireless, cellular, and other communication technologies. Exponential and complex computations, such as those used for medical research, civil engineering, and space exploration, are enabled by processors, memory, and programming languages. Computers enable the saving of documents and data to disk storage, eliminating the extra storage space needed for stacks of paper. Businesses thrive on digital data storage, and whether it's medical images, car claims, research records, or family photos, saving digital images provides durable and long-lasting access to that information. Finally, editing capabilities eliminate the time-consuming drudgery of having to erase and rewrite work manually. In this video, you learned that, based on size and speed, supercomputers are the fastest, followed by mainframes, then mini-computers, and finally microcomputers, which include PCs, laptops, smartphones, and others. Computers can perform general functions or specific functions. The 4 functions of computing are input, processing, output, and storage. And the benefits of computing include reducing the number of tasks humans need to do, enhanced data storage, the ability to perform complex mathematical tasks, and faster communications. Welcome to Common Computing Devices and their platforms. After watching this video, you will be able to categorize common computing devices and describe their main features and benefits, and identify frequently used operating platforms associated with these devices. Common computing devices include stationary computing devices, mobile computing devices, and Internet of Things or IoT devices. Stationary devices, which include workstations, servers, and tabletop gaming consoles, remain on a desk or rack or other fixed location. These devices consist of a box that includes processors, memory, and input and output connections that connect to networks, keyboards, monitors, mice, printers, speakers, microphones, webcams, and other devices. In some instances, you can update the device's memory, storage, or video cards. Let's explore workstations. Workstations, used both at the office and at home, are what most people think of when they think about a desktop computer. Also categorized with personal computers, these devices are typically in a box that contains a system board with a processor, memory, storage, and slots for add-on cards for additional functions. Their motherboards have ports that support monitors, keyboards, mice, microphones, printers, speakers, and other devices, as well as onboard cards for wireless connectivity. Many newer devices enable memory, storage, and graphic card upgrades. These devices use Microsoft Windows, Mac OS, and Linux operating systems. Next, servers are generally installed as standalone units or in stacked racks on networks, enabling shared access to media, such as movies, videos, and sound clips and web pages for websites. Servers also manage print requests, enable shared data and document access, store email, and more. On the network, multiple servers can contain the same data, so that if one server fails, users can keep working using the same data from other servers. The ability for work to continue if a shared computing resource is malfunctioning is known as fault tolerance. Server hardware offers robust capabilities that often support multiple processors, memory, graphic cards, storage, and port connections within the same box. Servers use network operating systems geared towards optimizing data distribution. Popular operating system software vendors include Microsoft Windows Server, Linux, Unix, Mac OS X, and FreeBSD. Desktop gaming consoles are also known as tabletop gaming consoles. Gaming console system boards contain processors, memory, graphics processors, storage, input ports, output ports, and a memory controller that exists separately between the other function blocks and the system memory. In times past, many of these functions existed separately as multiple chips on the motherboard, but today these functions exist in a single functional block. Gaming consoles, such as those made by Microsoft, Sony, and Nintendo, are similar to desktop computers but use upgraded memory caching and graphics processing to enable smoother game-playing experiences. Gaming consoles used to require cable connections to monitors and gaming controllers. Today's gaming consoles provide wireless connectivity. Gaming consoles are not usually upgradable. Mobile devices, including laptops, tablets, mobile phones, and portable gaming systems, have transformed how we live, work, and play. Let's first check out laptops. Many laptop computers run versions of Microsoft Windows, Mac OS, and Linux operating systems, while others use Google Chrome's lightweight operating system. Laptop system boards include processors, memory, video cards, ports for connecting to other devices, and Wi-Fi capability. Many laptop manufacturers allow upgrades to storage and memory. Tablet devices are usually less powerful than laptops, but that is beginning to change. Tablets built in very tight cases include most laptop components, but don't include a keyboard. Tablets generally use operating systems such as Microsoft Windows, iOS, and Chrome. The system board includes the device's processor, memory, a video card, sound card, a limited number of ports, a Wi-Fi card, and limited hard drive storage. Tablets are usually not upgradable. Mobile phones include onboard components with specialized processors, memory, sound, and video capabilities. Phones can include a slot for a SIM card that links the phone to a cell phone access provider and a slotted port for additional storage. All phones include one multifunctional port primarily used to recharge the phone's battery. Mobile phone operating systems built for speed are specifically designed to support multiple communication spectrum capabilities, including the designated cell phone frequencies, Bluetooth, Wi-Fi, near-field communications, and other connectivity options. Android and iOS operating systems dominate the market, but with practically all components welded onto the board, you can only upgrade the software, not the hardware. Portable gaming devices use specialized processors, storage, and memory, and include battery and multi-use ports for power, Wi-Fi, and other connectivity options. These devices use operating systems specially configured for mobile use, and many of those operating systems are Linux-derived. Gaming software is usually on board or downloadable, and the hardware is generally not upgradable. Internet of Things, known as IoT devices, describes physical objects that have sensors, processing ability, software, and other technologies that enable these devices to exchange data with other devices and systems over the Internet or other communications networks. IoT devices communicate via Wi-Fi, Bluetooth, NFC, Zigbee, and other protocols. They can receive software updates, but generally, the hardware within a limited space is soldered to the board and is not upgradable. Let's learn more. Widely available consumer IoT devices include smart speakers, TVs, wearable devices such as fitness trackers, and appliances such as automatic floor vacuums, stoves, and others. Light bulbs, toys, thermostats, and medical devices are also part of today's IoT world. Enterprise IoT devices enable organizations to offer consumers more targeted features and manage costs. For example, utilities install smart meters to help both residential and commercial customers manage their energy usage. Occupancy sensors and IoT-enabled security systems help businesses prevent losses and enhance worker and customer safety. Similarly, industrial IoT devices help organizations monitor the weather, operate robots, assess water and air quality, and more. In this video, you learned that common computing devices currently fit into 3 categories: stationary devices, mobile devices, and IoT devices. Desktop computers, mobile computers, and IoT devices feature a processor and input and output ports or capabilities. Desktop machines usually offer the most upgrade capabilities, while IoT devices are generally not upgradable. And desktop operating systems include Microsoft Windows, Mac OS, Linux, or Unix, while Google Android, Google Chrome, and Apple's iOS operating systems dominate the mobile operating system market. Welcome to understanding how computers talk. After watching this video, you will be able to describe 3 widely used notational systems, convert numbers between notational systems, identify common data types, and identify the 2 most widely used character types. In computers, a notational system, also called a numeral system, is a system of symbols that represent numbers. The 3 most widely used notational systems are decimal, binary, and hexadecimal. Decimal notation is base 10, as in numbers 1 through 9, then 10, 20, 30, and so on. Decimal notation uses a decimal mark, usually a period, which identifies the numbers to the right of the period as a fractional amount. Decimals with negative values display a minus symbol immediately left of the number. Binary notation is the base system for computer speak and programming in bits, but more commonly referenced in bytes. Binary uses only 2 numbers, 0 and 1, and combinations of those 2 numbers. Binary notation represents 0 as an off state and the number 1 as an on state. A single digit is known as a bit and is the smallest piece of computing information computers process. The next size of computing information is a byte. 8 adjacent bits, or digits, create a byte. To convert decimal numbers to binary numbers, divide your starting number and each subsequent quotient by 2 until the quotient equals 0. For example, start at the top of the column with the decimal 25. Divide 25 by 2 and note the remainder. Now divide the quotient 12 by 2 and note the remainder again. Repeat these steps until you get 0 as the quotient. For your final step, write the remainders so that the last remainder for 1 divided by 2 is written first, followed by the other remainders reading from bottom to top. So the binary equivalent of 25 is 11001. Here's how to change a number from binary to decimal using the doubling method. Let's start with the binary number 010010. Start with the leftmost digit, which is 0. Since you are starting from the leftmost digit and there is no previous digit to the leftmost digit, we consider the double of the previous digit as 0. Double the previous number and add the result to the current digit. Continue the same process for the next digit, which is 1. Now double the previous digit and add the number to the current digit. In this example, you get 0 times 2 plus 1, which is 1. Repeat the process for each number, moving to the right one digit at a time. The result of converting the binary number 010010 to a decimal using the doubling method is 18. Next, the hexadecimal notation system, often shortened to hex, is made up of 16 symbols using the numbers 0 through 9 and the letters A through F to represent decimal numbers 10 through 15. Hex offers compact notation for large numbers. Hex is used for MAC addresses, which identify where the device resides on the network, similar to your home address, color values, IP addresses, which are website addresses, and memory addresses, which identify where data exists within the computer's storage. The first column displays decimal numbers from 0 to 10. The second column displays the decimal numbers hex equivalent. The third column displays the decimal and the hex numbers binary equivalent. In this example, reading left to right, you can see that the decimal 10 is equal to A in hex and 1010 in binary. Many websites offer conversion tables where you can quickly convert numbers to their decimal, hex, and binary equivalents. To convert a hex number such as 123A into binary, follow these steps. First, note the hex number and represent each hex digit by its binary equivalent number. Next, add insignificant zeros to the left if the binary number has less than 4 digits. For example, write the decimal 10 as 0010. Then string each of the converted binary numbers together, working from left to right. This process is called concatenation. Your fourth and final step is to discard any leading zeros at the left of the concatenated binary number. For this example, let's use the hex number 123A. Use the table to convert each hex digit in 123A to binary, adding zeros to the left of the number if necessary to make the number a 4-digit number. Then string all 4 groups of 4-digit numbers together. On the leftmost binary number, discard any leading zeros, so 0001 becomes 1. Your result is 1001, 0001, 11010, the binary equivalent of the hex number 123A. Computers follow sets of instructions to perform tasks such as calculations, word processing, and web browsing using the following data types to process and present that information. Characters represent single letters. Strings show combinations of characters. Integers display whole numbers, such as the number 8. Floats represent decimals and fractions. And Boolean values provide yes or no and true or false statements. ASCII, first published in 1963, is the American Standard Code for Information Interchange format that translates computer language into understandable text. To save on transmission costs, ASCII was originally a 7-byte system, representing 128 binary characters. The system expanded to 8 bytes, providing another 256 characters. The displayed chart shows binary, ASCII, and hex equivalent numbers. You'll find similar charts online. Unicode includes ASCII characters, characters from languages worldwide, as well as emojis. More than 95% of the world's web pages use Unicode 8-bit encoding, commonly called UTF-8. Programming languages tend to use Unicode 16-bit, referred to as UTF-16, and a few programming languages use Unicode 32-bit encoding. Unicode provides a unique hexadecimal value for each character called code points. The default encoding format is usually shown as U plus HHHH, where the HHHH is the character's hexadecimal value. You'll find numerous conversion services online. In this video, you learned that bits and bytes are the base language of computer communications, and 8 bits equals 1 byte. MAC addresses, colors, IP addresses, and memory addresses use hexadecimal notation. Programs can read ASCII character text, strings, integers, floats, and Boolean data. And Unicode text, namely UTF-8, is used to display character sets on web pages. Welcome to an Introduction to Operating Systems. After watching this video, you will be able to describe what an operating system is and describe the functions operating systems manage, classify types of operating systems, describe operating system generations, and describe the history of Linux, Windows, Mac OS, and Chrome OS operating systems. Operating systems provide standardized backbone code for managing input, output, processing, and storage. These efforts help keep data error-free and mitigate data loss. Operating systems can have more than one environment. The first environment, the Command Line Interface, or CLI, is an environment where the user can type commands. The second environment is known as a graphical user interface, or a graphic shell. These environments provide menus, links, buttons, and fields that help users manage the operating system. History groups operating systems into 4 generations. The first generation was from 1945 to 1955. The second generation happened from 1955 to 1965. The third generation lasted 15 years from 1965 to 1980. And 1980 ushered in the fourth and current generation. During the first generation of modern computing, from 1945 to 1955, operating systems that worked for multiple computers did not yet exist. Each computer's parameters were uniquely created for every job or task using machine language. However, some of the code developed during this era became the basis for future operating systems. During the second generation of operating systems, mainframe computers became available for commercial and scientific use. Tape drives, a relatively new invention, provided input and output storage. In 1956, General Motors Research produced the first single-stream batch operating system, notably for its IBM 704 computing system. Subsequently, IBM became the first company to create operating systems to accompany computers. Embedded operating systems developed in the early 1960s and still in use focus on a single task, providing split-second response times, also known as low latency. In case of a system error, these operating systems can restart where the task needs to resume. Real-time operating systems are a type of embedded operating system. Airplanes, air traffic control systems, and space exploration were among the first to use real-time operating systems. As time passed, satellite systems, robotics, and even our cars implemented real-time operating systems. Then, during the third generation of operating system development, additional companies began creating batch file operating systems specifically for their large computing needs. This generation of operating systems saw the development of network operating systems that provided scalable, fast, accurate, and secure network traffic and communications, and enabled each workstation within the network to operate independently. In 1969, the Unix operating system offered a new innovation, an operating system that was installable on multiple computer systems and featured processor time-sharing. Processor time-sharing enabled multiple users with different programs to interact nearly simultaneously with a central computer, such as a mainframe. The fourth and current generation of operating systems brought computing into a new age with multitasking operating systems, including Linux, Windows, Mac OS, and Chrome OS operating systems that enable computers to perform multiple complex tasks simultaneously. Mobile operating systems including Android, Windows, iOS, and Chrome OS, which is also considered a mobile operating system, fit the definition of multitasking operating systems. Let's learn more about some of these operating systems. In 1991, Linus Torvalds created a small open-source operating system for a PC, releasing version 1.0 of Linux in 1994. In 1996, the version 2.0 release, with support for network-based symmetric multiprocessing, or SMP, provided a serious technical benefit for commercial and scientific data processing, evolving Linux into a powerful network and server operating system. Throughout the next 10 years, Linux gained market acceptance, and its distributions continued to mature. In 2013, Google's Linux-based mobile operating system, Android, took 75% of the market share. When evaluating the value of Linux, consider that in 2018, IBM acquired Red Hat for $34 billion. The operating systems PC-DOS and MS-DOS once existed, with MS-DOS launching in 1981. In 1985, Windows offered the consumer market a graphical user interface version of the Windows operating system, written in variations of C language. In 1995, the debut of Windows 95 catapulted Microsoft's dominance in the consumer operating system software market, with Microsoft holding about 70% of the consumer desktop operating system market share in 2021. Microsoft also offers network, server management, mobile, and phone operating systems. Apple, with its OS X and Mac OS based on Unix, began its foray into the operating system market in 1999 with PowerPC-based Macs. In 2006, Apple began selling Macs using Intel Core processors. In 2020, Apple began the Apple Silicon chip transition, using self-designed 64-bit ARM-based Apple M1 processors on new Mac computers. Apple also offers the iOS operating system for its tablet and smartphone devices. In 2011, Google debuted Chrome OS built atop Linux. Chrome OS offers a lightweight operating system for mobile devices, including laptops. Laptops and tablets running Chrome OS require less local storage and cost less, making them ideal for students, and this operating system is currently used by about 10% of the laptop market. In this video, you learned that operating systems provide standardized code that eliminates the need to manually recreate all the possible code necessary for input, processing, output, and storage for every computer action. In 1956, GM Research created the first operating system that is also credited as being the first single-stream batch operating system. Linux evolved into a powerful operating system for networks and servers. With the creation of Windows 95, Microsoft began its domination of the consumer operating system market. And Chrome OS, built on top of Linux, is a lightweight, primarily browser-based operating system. Welcome to Getting Started with Microsoft Windows 10. After watching this video, you will be able to identify 4 Windows login methods, describe how to use the Windows desktop, explain how to find the Settings app, explain how to resize windows and switch programs, and identify Windows keyboard shortcut commands. Microsoft Windows 10 provides 4 easy methods to log into a machine. You can log in using a PIN, a password, by drawing over a photo that you previously set up, or by scanning the fingerprint that you previously paired with the computer. Next, let's check out parts of the Windows desktop. Click the Windows icon to view the Start menu and Productivity pane. On the left side of the Start menu, you can see which user is logged on and shortcuts to documents, pictures, settings, and power management options. Available programs are organized alphabetically. If you right-click a program's icon, you can see menu options to uninstall the program, pin the program to your taskbar, run the program with administrator rights, and open its file location. To the right of the Start menu is the Productivity pane, which consists of a mixture of live and static tiles. Static tiles are shortcuts to favorite and frequently used programs, and live tiles provide a quick view of information such as news, weather, and sports. Right-click any tile to remove the tile, uninstall the program, or perform other tasks. At the bottom of the screen, the Windows taskbar provides access to the Windows Start button where you can open the Start menu. Next is the taskbar search box, where you can search for files, settings, and programs on the computer, or perform a quick web search. The circle icon provides a shortcut to Talk to Cortana, and the film strip icon provides access to Windows Task View. Next, access File Explorer. Settings lets you access an app that customizes the toolbar. On the right side of the taskbar, you can see the current weather, an upward caret that you can click to display the news, the Windows Meet Now icon that opens a video conferencing program, access to OneDrive, shortcuts to Wi-Fi and wired network access, speaker volume settings, time and date settings, and notifications. When you have time, explore taskbar customizations by using the Settings app, selecting Personalization, and selecting Taskbar. Notifications are a convenient way to view the news you want to see, receive app notifications, and more. On the taskbar, click the Notifications icon to display your notifications. Click Manage Notifications to customize the notifications you see. Clicking Manage Notifications opens Notifications and Actions, which is located within the Settings app. Here you can set notification preferences, including getting app and vendor notifications, showing notifications on the lock screen, allowing notifications to play sounds, and other settings. Next, let's learn about the control buttons used to resize, maximize, and minimize windows on the desktop. To resize a window, hover over the edge of the window to display the double-headed arrow. Then drag the double-headed arrow to resize the window. You can quickly maximize a window by clicking the rectangle, and if you need to minimize the window, click the underscore button. To close a window, click the X. You'll see the X shaded in red to remind you that you are about to close an active window. Now, you can quickly locate and switch windows by pressing the Alt and Tab keys. Your screen will display windows using a carousel format. Keep the Alt key pressed and repeatedly press the Tab key each time you want to switch to the next window. Then, click and hold to display the selected window. Let's check out more keyboard shortcuts. Keyboard shortcuts save valuable time and reduce errors, resulting in productivity gains to benefit the business. Windows provides numerous keyboard shortcuts, many more than are listed here. Often new users become confused when they see the first key and the second key with a plus sign in between, so we've shown them here as the first key, the second key, and, if needed, the third key. To copy your file or content, press Ctrl-C. To paste or insert a file or content, press Ctrl-V. To delete a file or delete content, press Ctrl-D. To repeat an action, such as inserting rows or columns, or a series of words, press Ctrl-Y. To undo the previous action, press Ctrl-Z. To edit the file name, press Ctrl-O. To restart the computer, press Ctrl, Alt, and Delete. And to capture a screen image, you can use the Print Screen button displayed as PRT-SCR, or the Windows Start key and the Print Screen button. In this video, you learned that you can log into Windows using a PIN or a password by drawing over a photo that you previously set up or by scanning your fingerprint. The Start menu provides shortcuts to documents, pictures, settings, and power management options. If notifications are interrupting your workflow, open the Notifications panel, click Manage Notifications, and then turn off notifications. To resize a window, Hover over the edge of the window to display the double-headed arrow, then drag the double-headed arrow to resize the window. Using the Alt and Tab keys is a fast way to locate an open window that you're not currently viewing. And finally, Windows keyboard shortcuts save you valuable time performing frequent tasks. Hello and welcome to Using Your Windows Lab Workspace. We're excited for you to take these next steps in your skills journey. The labs in this course and other courses provide you with a virtual, hands-on lab environment where you can boost your skills by practicing what you've learned in your course videos and readings. Your lab space, also known as a guided project or the My Cloud Workspace window, contains all the software you need to successfully complete your lab tasks. You'll also open a lab instructions file. For your best experience, we recommend displaying your lab space and instructions side by side. To access your hands-on lab, first open the item in the course for the hands-on lab. If the lab instructions display in a new tab, hover over the tab and pull the tab down onto the desktop. You can drag the window edges to resize the window to about 1/3 of the screen size. You'll return to this window later. Return to the course screen and scroll through the displayed course lab instructions. Select the checkbox to accept the Coursera Honor Code conditions. Then click the Open Tool button. Next, you'll see the Coursera Guided Project window. This window may take a moment to display. The displayed My Cloud Workspace window is divided into two panes. The left pane is named the Cloud Workspace window, and the right pane is named the Instructions window. You won't use this instructions window. Now, you can expand the Cloud Workspace pane on your screen's left side using one of two methods. Drag the vertical slider between the Cloud Workspace and the Instructions pane to the far right side of the screen, or click the Expand Cloud Workspace window button displayed on the top right of the left pane. Take a moment to view your lab window. You can click the lab window resolution drop-down arrow to adjust the size of the on-screen icons in the Cloud Workspace. And next, let's adjust your browser windows to see your Cloud Workspace and lab instructions side by side. On the Cloud Workspace lab window, hover over the double box icon located in the top right of the browser window to reduce the size of your window. Move the window to the left side of the screen. Now, drag the window's right edge so that the Cloud Workspace lab window uses about 2/3 of the available desktop space. Next, select the browser window that displays your lab instructions. Drag the instructions window so that the window is to the right of the Cloud Workspace lab window. Now, you can perform the lab tasks in the Cloud Workspace window while using the lab instructions. After completing the lab, select Leave Session to close the Cloud Workspace window, then close your lab instructions using the option available for your browser. Also, before you begin, here's some extra information you need to know. Each time you connect to these labs, Coursera creates a fresh new environment. Data or files you saved in a previous session are no longer available. To avoid losing your data, plan to complete your lab tasks in a single session. These labs are timed to provide enough time to complete lab tasks, but if you leave the lab session unattended, your lab may time out or end. Now, these setup instructions used a Chrome browser within Microsoft Windows 10. Other browsers and web browsers on Mac or Linux computers may use different navigation. You're now lab ready. Let's get started. Welcome to Identify Hardware Components and Peripherals. After watching this video, you will be able to explain the difference between internal and external components, describe what a peripheral device is and what it does, and apply your learning to contrast, an interface, a port, and a connector. What is a computer component? It's a physical part needed for computer functioning, also called hardware. And each component performs a specific task. Components can be internal or external. External components connect via ports, which are openings on the sides of a computer. Without a given component, such as a CPU, a computer system cannot function as desired. An internal component is a piece of hardware inside the computer. Examples include random access memory, or RAM, which is the computer's working memory and is temporary, storing items you are working with as long as the power is on. If you are working on a document and the power goes off, the document is lost. The hard drive is permanent storage that you can save a file to. A file stored on the hard drive is permanently stored and will not be lost if the power fails. And the CPU does all the math calculations in a computer. It's often called the brain of the computer. The faster the CPU, the more things the computer can do at a given time. A peripheral is a device which connects to a computer to provide extra functionality. It is used in the transfer of data to or from a computer. Peripherals can be easily connected to and removed from a computer system. Peripherals attach to the computer through a connector, and the type of connector varies with the peripheral. Examples include a mouse, keyboard, and printer. There are 3 kinds of peripherals: input devices, which send commands and data to the computer, output devices, which receive commands from the computer, and storage devices, which are a type of permanent memory for files you want to keep indefinitely. A connector is the unique end of a plug, jack, or the edge of a card that connects to a port. For example, all desktop computer expansion cards have an internal connector that allows them to connect in a slot to the motherboard. A universal serial bus, or USB connector, at the end of a cable is an example of an external connector. A connector plugs into an opening on a computer called a port. A port is the jack or receptacle for a peripheral device to plug into. Ports are standardized for each purpose. Some common ports are universal serial bus or USB ports, and high-definition multimedia interface or HDMI ports. The HDMI port pictured here could be used to connect a monitor. In this video, you learned that a component of a computer is a physical part needed for computer functioning. Examples of internal components include memory and a hard drive. Examples of external components include ports and connectors. The end of a plug or cable is called a connector. Connectors fit into one specific type of opening called a port. And a peripheral device can connect externally or internally. Hello and welcome to Input and Pointing Devices. After watching this video, you will be able to compare input devices, identify which devices use a touchpad, and define a pointing device. A pointing device, such as a keyboard, mouse, joystick, touchpad, or trackball, is used to move the cursor on a computer screen. All pointing devices send a command in the form of data to the computer. Keyboards are used primarily to input data. Keyboards typically attach to the computer via a universal serial bus or USB port, although older machines may use an IBM Personal System 2 PS2 port. To add a new keyboard layout on Windows 10, use these steps. Open Settings, select Time and Language, select Language. Under the Preferred Languages section, select the default language. Select the Options button. Under the Keyboard section, select the Add a Keyboard button, and select the new keyboard layout you want to use. You can repeat these steps to add even more layouts. The most used input device, used primarily to input data and move the cursor, is the mouse. A mouse generally connects to a computer via a USB port, which is a wired connection. You can also connect a mouse via a wireless Bluetooth connection. You can change the mouse settings, such as the size of the cursor in Windows settings. Touchpads are most often used on laptops. Touchpads are built into laptops and don't need to be connected externally. However, you can purchase an external touchpad for a laptop and connect through USB or Wi-Fi. The camera is another input device that produces a digital image on the computer. A camera generally connects to a computer via a USB port, which is a wired connection. You can also connect a camera via a wireless Bluetooth connection. Cameras are typically built into laptops and don't need to be connected externally. However, you can purchase an external camera for a laptop and connect through USB or Wi-Fi. A joystick sends commands to the computer. It moves the cursor and is often used to play games. You can connect it to the computer through a USB cable or wireless Bluetooth connection. Trackballs also send commands to the computer, although they have been largely replaced by computer mice. People with mobility issues might find the trackball to be a more comfortable alternative to a mouse. A pointing device is a type of input tool. As such, you can use it to move the cursor and additional commands to the computer. A pointing stick, or stylus, is usually used on tablets. Most styluses work via capacitive technology, which is about heat and pressure. When you push the stylus onto the screen, it senses the heat and pressure and elicits a response. In this video, you learned that input devices move the cursor and send commands to the computer. Common input devices include the keyboard, mouse, touchpad, joystick, and trackball. A touchpad acts like a mouse. It's usually built in and found on laptops. And a pointing device or stylus is used for navigation and to send commands. Welcome to hard drives. After watching this video, you will be able to identify an internal storage device, describe the characteristics of a hard drive, and apply knowledge of hard drive performance to choose the best one. A storage device is hardware that can be used to store digital data in the form of images, video, audio, and text. There are two kinds of internal storage, ROM and RAM. ROM stands for read-only memory. It is non-volatile, which means it can retain data even without power. It is used to start or boot up a computer and for permanent data storage. RAM, or random access memory, is the opposite of ROM. It is volatile or temporary storage. The hard disk drive, or HDD, is one type of internal storage device, but external hard drives exist. Hard drives are available from several vendors in both formats. Hard drive and hard disk drive, or HDD, are used interchangeably. Hard drives work by a drive head reading and writing data to magnetic platters. The 2.5-inch hard disk drive is used in notebook computers and mobile devices. They trail the 3.5-inch desktop drives in capacity. Standard hard drives for desktops run from 500 gigabytes or smaller to as large as several terabytes, or TB, or larger. But given the accessibility of cloud storage, the everyday user doesn't usually need a large capacity hard drive. Serial Advanced Technology Attachment, or SATA, is the most common hard drive type for modern computers, though many motherboards support Parallel Advanced Technology Attachment, or PATA drives, which are slower than SATA drives. To evaluate disk storage capacity and availability in Windows 10, on the taskbar, type "This PC" and press Enter. Select Open. The window for this PC displays. Then, within Devices and Drives, view the available disk space. Hard drive performance is measured by spin speed, access time, and transfer rate. Spin speed, or RPM, is how quickly the magnetic platters rotate. The platters need to spin faster to increase performance in a hard drive. So, the faster the platters spin, the better the performance of the hard drive. The two most prevalent speeds in hard disk drives, or HDDs, are 5400 rotations per minute, or RPM, and 7200 RPM. Access time refers to how quickly the hard drive can find stored data on one of the magnetic platters. Access times of fast hard disks are typically from 5 to 10 milliseconds. And the transfer rate, sometimes called media rate, is the speed at which data is transferred to and from the disk media, or actual disk platter. It is described in megabytes per second, or Mbps. Follow these steps to install an internal hard drive. First, be sure to back up your data before connecting an internal hard drive. Transfer the hard drive enclosure to the new hard drive if present. Some computers use a special enclosure to secure the hard drive. If your hard drive has an enclosure for the hard drive, remove all the screws and pull the old hard drive out. Place the new hard drive in the same enclosure and secure it. Insert your new hard drive in the hard drive slot. Then secure the hard drive using the screws that came with it. Ideally, you should use 2 screws on each side of the hard drive. If the hard drive is loose, it can rattle and lead to physical damage. Now, attach the drive to the motherboard using the SATA or PATA cables. SATA cables can be connected in either direction. And finally, connect the power supply to the hard drive. To configure a hard drive in Windows, you must log on as an administrator or as a member of the administrators group. Right-click on My Computer, then select Manage, and in the console tree, select Disk Management. To customize how you view your disks and volumes in the upper and lower panes of the window, point to top or bottom on the View menu, select the view that you want to use, and make your choice of appearances. In this video, you learned that hard drives are a repository for images, video, audio, and text. Hard drives are read-only memory, or ROM, which is permanent storage. Hard drives have distinct characteristics and performance measurements such as spin rate, transfer speed, and data capacity. You should evaluate how much storage space you need before installing a new hard drive, and you should follow the correct procedure when installing a hard drive. Data should be backed up before connecting a new hard drive, and finally, hard drives can be configured in the Device Management window. Welcome to Optical Drives and External Storage. After watching this video, you will be able to identify how an optical drive records data, describe an external storage device, and apply knowledge of expansion devices to choose the best one for your needs. Data is written to optical devices through a laser pressing or burning the disk. This creates recessed areas known as pits and raised areas known as lands. The laser reads and writes data on the reflective surface of the disk. Single-sided disks have one recordable layer to write data to. Storage capacity is usually 4.7 gigabytes for a DVD-ROM and 700 megabytes for a CD. Double-sided disks have 2 layers on which to record data. They hold twice as much data as a single-layer disk. There are many types of optical drives. These include CD-ROM, CD-RW, DVD-ROM, DVD-RW, and Blu-ray, which has a data capacity of 50 gigabytes, or 50 GB. CD and DVD writers, such as CD-R and DVD-R drives, use a laser to read and write data on the disks. A solid-state drive, or SSD, uses integrated circuit assemblies to store data, typically using flash memory and functioning as permanent secondary storage. It is also sometimes called a solid-state device or a solid-state disk, even though SSDs lack the physical spinning disks and movable read-write heads used in hard disk drives, or HDDs, and floppy disks. An external hard drive is an excellent medium to back up and transfer files. They can store large amounts of data, including documents, spreadsheets, presentations, music, and videos. Most external hard drives connect to a computer through a USB or eSATA connection. Many draw power from the computer's USB port. External SATA or eSATA is a SATA connector accessible from the outside of the computer to provide a signal but not power. If the external hard drive requires a power cord, connect it to the back of the hard drive. The end of the power cord that connects to the hard drive is usually a small round connector. Connect the other end of the power cord to a power outlet. If no power cord is required, skip to the next step. Connect the USB cable to the external hard drive and plug the other end of the USB cable into a USB port on the computer. After connecting the external hard drive to the computer, it should be recognized automatically by your computer's operating system. Your computer should find and install any necessary drivers. In Windows, File Explorer may automatically open, displaying the contents of the external hard drive. If File Explorer does not automatically open, manually open File Explorer and locate the drive. An expansion drive provides extra storage for an ever-growing collection of files. It typically attaches to the computer with a USB connection. Expansion drives consolidate files into a single location and frees computer space. The drive is automatically recognized by the Windows operating system, so there's no software to install or configure. One example of an expansion drive is a USB or thumb drive. These drives have a storage capacity of up to 2 terabytes or 2 TB. A USB flash drive is an expansion device that includes flash memory with an integrated USB interface. It is typically removable, rewritable, and much smaller than an optical disc. Most weigh less than 1 ounce. Since first appearing on the market in late 2000, as with virtually all other computer memory devices, storage capacities have risen while prices have dropped. As of 2018, 2 terabyte flash drives were the largest available in terms of storage capacity. Some are thought to last 10 to 100 years under normal circumstances or shelf storage time. A memory card is used to store digital information, typically using flash memory. These are commonly used in portable devices such as digital cameras, cell phones, laptop computers, and portable media players. The card is stored inside a device. This differs it from USB drives. Memory cards are available in both secure digital, or SD, and micro-secure digital, or MSD formats. Common digital capacities are 32 GB, 64 GB, and 128 GB. Some of the latest generation memory cards offer 512 GB memory card capacities. Portable media players and smartphones are other types of storage devices. A portable media player is any type of electronic device that is capable of handling digital media. Depending on the device, the types of media files that can be played include digital music, audiobooks, and video. A mobile media player is often part of a smartphone. It is important to understand the difference between internal and external or expandable memory. Internal memory is the manufacturer-installed storage space, usually 16, 32, or 64 gigabytes, where the operating system, pre-installed apps, and other system software are installed. The total amount of internal storage cannot be increased or decreased by the user. So if your phone has only 16 gigabytes of internal storage and no expansion slot, this is all the storage space you will ever have. And remember, some of this will already be used up by the system software. External or expandable memory refers to a removable micro SD card or similar format, but not all phones will have this extra storage capability included. If storage for music, images, or other user-added files is important to you, the ability to add another 32 gigabyte or even 64 gigabyte card should be an important consideration. In this video, you learned that optical drives record data using a laser on a reflective disk. An external storage device, such as an external hard drive, often connects to a computer via a universal serial bus or USB connection. External hard drives and USB drives are solid state, which means they've got no moving parts. They're faster and more expensive than traditional hard drives. The best storage option for you will depend on your needs and your budget. Smartphones and media players offer portable storage as well as extensive functionality. And solid-state drive or SSD media, such as external hard drives, USB drives, and memory cards, increase the storage capacity of a system. Welcome to Display Devices. After watching this video, you will be able to Define and identify types of display devices. Enumerate how to adjust display properties. And identify the installation and removal of display devices. A display device is a hardware component for the output of information in visual form. Visually impaired people can choose a tactile monitor that presents the information in a fingertip-readable format. Common applications for display devices are television sets and computer monitors. A cathode ray tube, or CRT monitor, is an analog device that creates an image on the screen by directing 3 electron beams over millions of phosphor dots to light them up. CRT monitors were commonly used in televisions and computer monitors throughout the mid to late 1900s. By 1990, IBM's Extended Graphics Array, or XGA display, boasted 16.8 million colors in 800 by 600 pixel resolution. Flat screens are also known as liquid crystal display, LCD, or thin film transitor, TFT monitors. A digital signal drives the color value of each picture element or pixel. They replace the larger and heavier analog CRT monitors. Touchscreens use a touch panel on an electronic display. Their capacitive technology measures heat and pressure. They are often found on smartphones, laptops, and tablets. Projectors are output devices that can take images from a computer and display them on a screen, wall, or other surface. The surface projected onto is usually large, flat, and lightly colored, such as a wall or whiteboard. The projected images are either still, like slides, or moving pictures. Screen resolution refers to the clarity of the text and images displayed on your screen. At higher resolutions, such as 1600 by 1200 pixels, items appear sharper. Older CRT monitors generally display a lower resolution of only 800 by 600 or 1024 by 768 pixels. You can change your screen resolution by selecting Settings, then System, and then Display. Windows uses plug-and-play installation. Windows locates and installs a device driver when you connect the device. Hot swappable devices, such as monitors, do not require a system restart to connect or disconnect. If you need to manually install a driver, locate the driver setup program from the vendor's website and then download and run it. To enable your PC to recognize multiple monitors in Windows 10, make sure your cables are connected properly to the monitors, press Windows key plus P, and select a display option. Your choices include Duplicate. This will copy your display to both monitors, or Extend, and this will project your display equally over 2 monitors. To uninstall a device in Windows, launch Device Manager by selecting the Start button, typing Device Manager, and pressing Enter. Then follow these steps. Open the View menu and select Show Hidden Devices. Expand the node that represents the type of device you want to uninstall, then right-click the device you want to uninstall, and select Uninstall. In the Confirm Device Removal dialog box, if you wish to remove the driver package in addition to uninstalling the device, select the Delete the Driver software for this device option. When ready to complete the operation, select OK. With some devices, if the device is still plugged in when it is uninstalled, the device might continue to function until the system has been restarted. In this video, you learned that a display device is a hardware component for the output of information. Types of display devices include flat screen and CRT monitors. The display resolution can be adjusted by using Device Manager. To install a plug-and-play display device, you need only attach it to the computer. And to remove a display device, use Device Manager to uninstall it. Hello and welcome to Printers and Scanners. After watching this video, you will be able to describe what an output device does, install a printer in Windows, and identify types of printers used by a computer. Input to the computer is processed as data and shown or output via an output device. An output device is any piece of hardware that converts information into a human-readable form. That output can be text, graphics, tactile, audio, or video. Examples of output devices include monitors, printers, speakers, headphones, and projectors, as well as GPS devices, sound cards, video cards, optical mark readers, and braille readers. A speech synthesizer produces verbal output like human speech. A computer can function without an output device. However, without an output device, there is no way to determine what the computer is doing. There is no indicator of errors nor the need for additional input. For example, if you detach your monitor from your computer, the computer will still function, but you won't be able to see anything. A printer is simply a machine for putting text or pictures onto paper. There are 4 main types: laser, LED, inkjet, and thermal. Laser or thermal printers use a heated unit to fuse ink onto paper. LED printers, like laser printers, have a photoreceptive drum that surface is positively charged with static electricity by a high-voltage wire. The paper then passes between 2 heated rollers, fusing the toner to the page before it comes out the printer. Inkjet printers have a print head containing thousands of tiny holes. These openings put microscopic droplets of ink onto paper very quickly. Inkjet machines use a liquid ink produced by either a colored dye or a liquid that contains solid pigments. And thermal printers heat specially coated paper to turn sections black and is used in point-of-sale terminals and fax machines. A networked printer is connected to a network using Ethernet or Wi-Fi, the latter being the more popular choice. Whereas a local printer would be cabled to the device that requires it, a networked printer can be accessed by multiple devices simultaneously on the same network. An IP-based printer is part of an IP network. It often refers to Unix computers that use a specific protocol for printing. Like an IP-based printer, a web-based printer can receive documents through a network and via the internet, rather than a direct connection to a computer. To install or add a local printer using Windows, follow these steps. Select the Start button, then select Settings. Then choose Devices and select Printers and Scanners. Select Add a printer or scanner. Wait for it to find nearby printers. Then choose the one you want to use and select Add Device. An image scanner or scanner optically scans images, printed text, or an object and converts it from an analog format to a digital image. This creates an electronic version of the document that can be viewed on a monitor or screen and edited on a computer. Commonly used in offices are variations of the desktop flatbed scanner, where the document is placed on a glass window for scanning. Flatbed scanners have been replaced by multifunction devices. More on those coming up next. A fax machine is a device that is used to send documents over a telephone network. The transmissions can be between 2 fax machines, or between a fax machine and a computer, or an online fax service. Often the functions of a printer, scanner, and fax machine are combined in one device, known as a multifunction device, or MFD. In this video, you learned that an output device is hardware that converts information into a human-readable form. Installing a printer in Windows 10 takes only a few steps. Printer types include inkjet, LED, laser, and thermal. Output devices display data from the computer in one or more formats. Scanner output can be selected in different formats, including a PDF. And multifunction devices, or MFDs, can be used instead of standalone printers, scanners, copiers, and fax machines. Welcome to Audio and Visual Devices. After watching this video, you will be able to define audio and visual devices, explore the usage of speakers, microphones, and headphones with computers, and evaluate the usefulness of webcams. On its own, your computer can't make a sound. Digital data from audio and video files need to be turned into something that our ears can hear, and this requires specialized hardware and processing in the form of audio devices. Audio devices refer to components that reproduce, record, or process sound. This includes microphones, CD players, amplifiers, mixing consoles, effects units, and speakers. Visual devices are units capable of presenting images electronically on a screen. Typically, such devices have a display greater than 4 inches when measured diagonally. Images can be displayed on smartphones, computer monitors, and laptop computers. A computer speaker is an output hardware device. It connects to a computer to generate sound. The signal used to produce sound is created by the computer's sound card. To configure your speakers in Windows 10, right-click the speaker icon in the taskbar's notification area or system tray and select Open Sound Settings to go straight to the Sound Settings screen. Locate the Output section on the sound screen, and in the drop-down menu labeled Choose Your Output Device, select the speakers you'd like to use as your default. A microphone, sometimes abbreviated as mic, is a hardware peripheral and input device. A microphone allows computer users to input audio into their computers. To install a new microphone using Windows 10, follow these steps. First, make sure your microphone is connected to your PC. Then select Start, then Settings, System, and Sound. Scroll to Input, choose your input device, and select the microphone or recording device you want to use. Sometimes referred to as earphones, headphones are a hardware output device that plugs into a computer line-out or speaker port. Headphones allow you to listen to audio without disturbing the people around you. To use a headset, you must connect it by one of 2 means. Attach one end of the headset to an available port on a PC, or link it via wireless. If you plan to use a wired connection, you might use a 3.5mm jack. Older and more affordable headsets usually have the cable split at the end with 2 3.5mm jacks, one for audio out and the other for the microphone. These connectors are green for the headset and pink for the microphone. The next option, if you plan on using a port, is to use a universal serial bus connection. USB-powered headsets offer enhanced experiences thanks to inline amps, controls, and other features that affect sound quality. Or you can use a wireless connection. Bluetooth headsets remove all the cables between the headset and your computer, allowing you to sit more comfortably without fear of creating a tangle of cables. A webcam feeds an image or video in real time to a network such as the Internet. Webcams can be used during a video chat and offer a compact video recording device. Once of very low quality, modern webcams are usually high resolution with 1080p or pixels or high definition HD. They can be built into laptops or attached using a universal serial bus or USB. Here's how to set up a webcam in Windows. Press the Windows key or click Start. Type Camera in the search box and select the Camera app. The Camera app opens and the webcam is turned on, displaying a live video of yourself on the screen. You can now adjust the webcam to center your face on the video screen. In this video, you learned that audio and visual devices, such as webcams and speakers, add multimedia functionality to a system. The sound quality of a speaker depends on the sound card. Headsets are available in a variety of connections and sound quality. Newer webcams offer HD or 1080p quality, and such webcams are useful in video chats. Welcome to Identifying Ports and Connectors. After watching this video, you will be able to define a port and a connector, differentiate between a port and an interface, and identify common ports and connectors. Devices connect to a computer using ports and connectors. A port is a hole or a slot that receives a connector and allows a device to physically connect to a computer. A connector is the distinctive plug at the end of a cable, jack, or electronic card that can be physically plugged into a port. Each port has a unique function and accepts only the connector designed specifically to fit into it. Common examples of physical ports and connector pairs include the USB port, HDMI port, display port, and speaker port. An interface is the point of communication between two or more entities. An interface can be either hardware or software-based. Examples of hardware-based interfaces include the point where a port or card connects to the computer motherboard, the point where a peripheral device connects to the computer, or a touchscreen device that records human inputs. Software interfaces provide routes for communication between software applications, the operating system, and hardware. For example, drivers are software interfaces that enable communication between the operating system and the computer's hardware components. Let's take a deeper look and learn to identify commonly used interfaces and connectors. The Universal Serial Bus, or USB, was built by a consortium of 7 companies to replace the many varieties of connectors available in the market with a common, simple-to-use, and fast standard that could be used across devices and peripherals. Since its launch in 1996, the USB connector has gone through several iterations. When USB was first launched, it supported speeds of 1.5 to 12 megabits per second. It also supported 4 different connector types: Type A, Type B, Mini A, and Mini B. USB 2 was launched in 2001 to increase data transfer speeds up to 480 megabits per second. It also added support for the Mini AB connector and introduced the Micro A, Micro B, and Micro AB connectors. The USB 3 series of updates saw speeds increase to 5 gigabits per second, with USB 3.0 in 2008. The Type-C connector was launched with USB 3.1 in 2014 with speeds of 10 gigabits per second. It was made backward compatible with all versions of USB up to USB 2. USB 3.2 was released in 2017 with speeds of 20 gigabits per second. The mini connector types were discontinued in this version. USB 4, based on the Thunderbolt 3 and 4 protocol specifications, was released in 2019 and continues to be the latest and greatest version for USB devices. It supports speeds up to 40 gigabits per second over a Type-C connector. The Type A USB port has an elongated rectangle shape with 4 pins and carries both data and power. It is typically used for keyboards and mice. The Type B port is almost square with beveled outside top corners. These also have 4 pins and are mostly used with printers, scanners, and similar devices. Mini USB ports were introduced for use with smaller devices such as digital cameras, mobile phones, and tablets. They have 9 pins and are smaller than Type A or B and twice as thick as micro USB ports. Micro USB ports are similar width as mini USB, but much thinner with only 5 pins. These were designed to replace mini ports on smaller devices. And finally, the 24-pin Type-C with a reversible connector is designed to be future-proof and to replace various Type A and B connectors. Thunderbolt is a commonly used hardware interface developed by Intel and Apple. It was originally marketed under the name Lightpeak, but was later renamed to Thunderbolt. The Thunderbolt interface is very versatile, combining data transfer, display, and power into one cable. It allows up to 6 peripheral devices to be connected through a daisy chain. Thunderbolt interfaces have 4 versions. Versions 1 and 2 use the same connectors as a mini DisplayPort or MDP. Versions 3 and 4 reuse the USB-C connector. While Thunderbolt 3 doubled the data transfer rate to 40 gigabits per second, Thunderbolt 4 has support for USB 4 protocol and data rates, and dual 4K displays. It also supports Thunderbolt Alternate Hubs USB, and not just daisy chaining. All Thunderbolt ports are identified using the Thunderbolt symbol to differentiate them from regular MDP and USB-C ports. Before Thunderbolt, FireWire was a popular interface on Macintosh computers and is comparable to the modern USB interface. It comes in various shapes. The 400 is a slimmer connection with one rounded side, and the faster 800 connector looks like a thicker version of the USB. FireWire ports use a serial bus architecture to transfer information one bit at a time. This makes them lighter and cheaper than parallel buses that use a number of different physical connections. FireWire interfaces have been replaced with Thunderbolt and USB interfaces on modern computers. However, users with older computers, as well as the automobile and aerospace industries, still use these ports. PS2 ports were developed by IBM for their IBM Personal System 2 series of computers and are named after them. They are round and have 6 pins for connectivity. These ports were specifically designed to connect the keyboard and mouse to the computer. Although the two PS2 ports look identical, they are not interchangeable and they are identified by different colors and symbols. And although the PS2 port is considered a legacy port, modern PCs may still carry them as they are preferred by gaming enthusiasts, legacy users, and industrial applications. eSATA is the most popular port to connect external storage devices, such as external hard drives, to computers. eSATA allows hot swapping, which is the replacement or addition of external devices without stopping, shutting down, or rebooting the host system. Since 2008, eSATA has been upgraded to the eSATA P interface that allows for both eSATA and USB devices to be connected through the same port. eSATA has been through 3 main revisions, and data transfer speeds have doubled with each revision. In this video, you learned that a port is a hole or slot that receives a connector and allows a device to connect to a computer. A connector is a plug at the end of a cable, jack, or electronic card that can be physically plugged into a port. An interface is a hardware or software-based point of connection between 2 or more entities that enables communication. And common ports and connectors include PS2, Thunderbolt, FireWire, eSATA, and USB. Welcome to Identifying Graphic Devices. After watching this video, you will be able to describe how graphic devices operate on a computer, list characteristics of the display system, and recognize the different types of display connectors and their use. Computers communicate with a display unit, such as a computer monitor, using display cards called the Graphics Processing Unit, or GPU. Generic graphic cards are built into a computer's motherboard and are good for everyday computing requirements. Graphic-heavy tasks, such as multimedia editing and 3D gaming, require specialized high-end graphic adapters. Radeon chipsets by AMD, GeForce and Enforce chipsets from NVIDIA, and other adapters from SIS, Intel, and VIA are popular products on the market. When selecting a computer display, the resolution, refresh rate, and bit or color depth all play an important part. The resolution is the number of horizontal and vertical pixels, which determines the clarity of an image or text. The refresh rate, based on how fast the screen refreshes to show a new image, governs the video playback quality, while the bit depth, which describes the total number of supported colors, dictates how close the colors are to real life. Higher resolutions, refresh rate, and bit depth result in higher quality images, smoother video playback, and true color displays. The display quality is directly linked to the amount of processing power required from the graphic processing unit, or GPU. It is, of course, possible to display low-resolution images and video on a high-end display, thereby reducing the need for graphic processing power. Initial displays used cathode ray tubes, or CRTs, with a 4:3 screen width-to-height aspect ratio. These displays supported video graphic array, or VGA standards. The earliest VGA standard supported 640 by 480 pixels with a 4-bit 16-color display at 60 Hz. This was superseded by the SVGA standard, supporting 800 by 600 resolution and 4 or 8-bit color. The next iteration, using XGA standards, supported 1024 by 768 pixel displays, 16 or 32-bit colors, and a higher refresh rate. All of these displays used a 4:3 screen width-to-height aspect ratio. With the advent of LED technology, widescreen monitors supporting 16:9 aspect ratios are common. These monitors support high-end resolutions from between 1280 pixels by 720 to 1920 by 1080 for a full HD display. Larger devices use even higher resolutions, such as 3840 by 2160 for 4K or Ultra HD displays, and 7680 by 4320 for 8K displays. Different display and graphic adapters come equipped with different ports that support different connectors and cables. Sometimes the same adapter may have more than one type of connector. Each connector represents an advancement in display technology and brings its own benefits. Let's take a look at each of these in greater detail. High-Definition Multimedia Interface, or HDMI, is the latest and most widely used interface for digital audio and video for televisions, Blu-ray players, computers, and other consumer electronics. Beyond just data transfers, HDMI also provides remote control or CEC support and digital content protection or HDCP. The HDMI connector has a proprietary 19-pin connector in 3 sizes: HDMI 2.1 for regular connections, HDMI Mini for portable electronics such as DVD players, and the micro HDMI for GoPro action cameras, smartphones, and so on. The newer versions of HDMI offer greater bandwidth and can therefore support higher quality resolutions up to 8K. Developed by the Video Electronics Standards Association, or VESA, DisplayPort is designed to complement HDMI and offer a royalty-free alternative. It improves upon the DVI interface and is the first to use packetized data transmission. This allows DisplayPort to transmit higher bandwidths over fewer pins, thereby resulting in almost lossless data transmission. The DisplayPort connector has 20 pins, where 12 are for the main link, 3 pins for the auxiliary channel, 1 for the hot plug detection, 2 for power, and 2 additional ground pins. It can support 7 different transmission modes for progressively increasing bandwidth. Intel and Apple developed the Thunderbolt interface, and this interface remains popular on Apple computers. This versatile cable type functions both as a display and as a peripheral interface. The initial version of Thunderbolt used the Mini DP interface. Thunderbolt version 3 and the current Thunderbolt version 4 both use a USB-C interface. However, it is important to know that a Thunderbolt device plugged into a standard USB-C interface does not support Thunderbolt features, and a USB-C cable plugged into a Thunderbolt interface does not support Thunderbolt features. Developed as an industry standard for digital video content transmission, DVI connects a video source to a display. It transmits uncompressed digital video and can support both analog and digital devices in various formats. The DVI-I interface supports integrated digital and analog equipment on the same connector, while DVI-A supports only analog equipment and DVI-D supports only digital equipment. The digital connectors come in single and dual link formats, where the dual link provides higher bandwidth for resolutions higher than HD TV or 1920 by 1200. This interface was very popular but has since been replaced by HDMI and Thunderbolt or DisplayPort interfaces. One of the earliest interfaces, the VGA, was developed for analog video transmission. Considering that most of the modern graphic devices handle digital content, the VGA is now considered legacy, although some PCs continue to support it. The VGA has a distinctive 15-pin array distributed into 3 rows. The connector can be secured to the port using screws. There are several other connectors used commonly that are worth mentioning here. Apple provides a free license for the Mini DisplayPort, and it can support up to 4K resolutions, so users can connect their computers to HD TVs starting from the 2010 version. Many popular laptop models ship with the Mini DisplayPort interface. Some displays use USB to connect. Universally, cameras use USB ports to connect to computers. Some display monitors also use USB Type-A connectors. And some older televisions, VCRs, and computer monitors use S cables to connect using the S video port. Component RGB is used to process analog video signals. These interfaces typically split video into 3 signals, and usually have 1 or more additional cables for transmitting the audio signal. In this video, you learned that computers need a display unit connected to a screen in order to display graphics and video. Quality of display is based on resolution, bit depth, and refresh rates. And higher quality display requires high-end specialized adapters. The current display systems use 16:9 aspect ratio with LED displays, while older models use CRT displays featuring a 4:3 aspect ratio. And there are different graphic connectors available, and each has its own features and benefits. Welcome to Identifying Audio Connectors. After watching this video, you will be able to describe how audio devices connect to a computer, list the different types of audio connectors, and identify audio connectors based on the connection type. Computer programs use an internal expansion audio card, also known as the sound card, to transmit audio signals into and out of a computer. These cards have a digital-to-analog converter to help external analog devices connect and communicate with the computer. Depending on the sound card, it can have ports to connect a variety of devices, such as headphones, speakers, microphones, video projection devices, and more. Sound cards are commonly used to listen to music, record and edit audio or video, play computer games, make presentations, and conduct teleconference calls. Audio input and output devices use different types of connectors, such as sound cards, Bluetooth, game ports or USB ports, and external audio interfaces. Let's take a look at each of these in more detail. The number of connectors or ports on a sound card depend on the requirements. These ports accept a 6.35mm tip, ring, and sleeve or TRS jack, or a 3.5mm TRS mini jack. The ports are usually labeled but are also color-coded for easy identification. At a minimum, a sound card offers a light blue analog line in, a pink microphone in, and a lime green audio line out connector. Sound cards with advanced features may also provide additional outputs, including black for left and right rear surround speakers and orange for mid-surround. Built-in Bluetooth connectors use a wireless interface to connect audio devices like headsets and speakers. Modern computers and laptops come with built-in Bluetooth adapters. However, external Bluetooth dongles are also available. These connect through the USB port to receive and transmit Bluetooth signals. Until the late 1990s, game ports used MIDI interfaces with the standard 15-pin connector. The 2 redundant pins, 12 and 15, were repurposed to transmit audio and enhance the gaming experience. Modern computers and gaming controllers use the USB port for both connectivity and audio, and the game port is now obsolete, except for backward compatibility with outdated devices. A single external audio interface can connect to multiple input and output devices, such as amplifiers, microphones, speakers, and so on. Professionals and studios use external audio interfaces for better quality and amplified sound. These external audio interfaces then connect to the computer via USB, Firewire, Thunderbolt, or similar digital connectors and require specific drivers to work. In this video, you learned that Computers use internal expansion cards, called audio or sound cards, to send and receive audio signals. There are a number of ways a computer can connect to audio devices through the sound cards. And the most common connectors are sound card ports, Bluetooth, game ports or USB ports, and external audio interfaces. Welcome to Wired and Wireless Network Connections. After watching this video, you will be able to describe network communication types, give examples of wired and wireless connections, and contrast wired and wireless connections. Today, hardly any device operates in isolation, unless that's what you want. Communication technology allows components to communicate over a network by converting information into data packets that are sent from one smart object to another in dialogue. Like papers in an envelope, each data packet contains information about the sending and receiving device, along with the message that needs to be transmitted. This ensures that only the designated device receives the information. As such, devices built to talk over a network can communicate with each other. A finite number of devices can be connected in a closed network or to an unlimited number of devices over an open network, such as the Internet. For example, your phone could be used to control your humidifier on your home network. Either type of network connection can be wired or wireless, such as Bluetooth. An RJ, or registered jack connector, is used for landline telephones. There are two types of RJ connectors. An RJ11 is used to plug a phone into a wall outlet and for connecting a handset to a telephone. RJ45 connectors are used for connecting computers and other Internet-enabled devices, such as wired credit card readers, servers, modems, gaming consoles, and smart TVs, to Ethernet-based local area networks or ELANs. The RJ45, like the RJ11, has a plastic tab to prevent misconnections between the connector and the port. Wired connections allow faster data transmission. This connection offers speeds up to 5 gigabits per second, while wireless connections have a speed of only 1 gigabit per second. They're more reliable than wireless connections because they have consistent speed and connectivity. Wired connections are not impacted by weather conditions and are immune to signal drops and dead zones. Wired connections are less prone to radio interference, so there are fewer dropped packets that need to be retransmitted. This translates into greater network stability and speed. As devices need to be physically connected in a wired connection, they are more secure and less likely to be hacked. Wireless connections use different technologies based on connection requirements. For example, wireless fidelity, or Wi-Fi, is used to connect computers, phones, tablets, smart TVs, and other devices to the Internet. It works by connecting a wireless router directly to an Internet modem. The router acts as a hub for all wireless-enabled devices within a range to connect to a home network and the Internet. Note that newer modems have built-in routers to avoid the need for connecting a separate device. Bluetooth technology, available since 1998, uses ultra-high-frequency radio waves to connect devices in a one-on-one connection over short distances. The connection between a sending and receiving device is established through a process called pairing, where both devices send a passkey to recognize each other. Radio frequency identification, or RFID, is used to identify and track objects using tags. RFID devices can operate over several hundred meters. RFID is used in the automatic collection of road tolls through tags affixed to vehicle windshields. Other uses of RFID tags can include implanting them in pets and livestock to enable easy identification, tracking pharmaceuticals through warehouses, preventing theft, and expediting checkout in stores. NFC, or near-field communication, is an evolution of RFID technology that works over extremely short distances. Near-field communication transmits data through electromagnetic radio fields to enable two devices to communicate with each other. To work, both devices must contain NFC chips. The short range makes NFC power efficient and increases security by eliminating accidental triggers. Common implementations of NFC include key cards for hotels and office access, digital wallets, and chip-enabled credit cards. Wireless networks are becoming increasingly commonplace because of their advantages over wired connections. For example, there's the increased mobility. Users can easily move from one location to another without losing connectivity most of the time. Wireless connections are extremely quick and easy to set up. On the other hand, wired networks require extensive cabling and equipment that must be installed and tested before the network becomes operational. As your networking requirements evolve, it is very easy to make updates and scale up in a wireless network. A wireless network can be easily extended to reach a wide area, including places where you cannot install network wires and cables. And wireless networks are more economical, as they require less equipment and are easier to scale and maintain than traditional wired networks. In this video, you learned that devices connect with each other using wired and wireless networks. The main types of wired connectors are the RJ11, which is used in telephony, and the RJ45 used to connect computers and related peripherals. Wireless networks use different technologies based on usage requirements. Wi-Fi connects devices to home networks and the internet. Bluetooth has a short range but transmits large streams of data. RFID uses a tag and receiver model to collect identifying information. It is useful in tracking products, livestock, and pets, and for collecting tolls on highways. And NFC is an evolution of RFID and operates over extremely short distances. It often requires physical contact between devices to transmit data. Welcome to Peripheral and Printer Connections. After watching this video, you will be able to list common methods for connecting to and installing printers and peripherals, describe how to connect printers or peripherals using serial ports and parallel ports, and describe how to connect printers or peripherals via a local or network connection. How does a computer recognize a peripheral device or printer? Computers require software that enables peripheral or printer device recognition and communication. Computers use onboard pre-installed plug-and-play software designed as generic software that can work with multiple printers, scanners, or other specific peripherals. For example, a generic printer driver could enable the installation of various brands of printers. If the device doesn't successfully install when trying a plug-and-play installation, your next step is to visit the manufacturer's website to locate and install the device driver that works with your operating system. Often, by installing the driver software, you can use the device's basic features. However, for example, if you have a peripheral device, such as a multifunction printer, and you want to use its additional features, such as scanning and faxing, manufacturers generally require that you download and install their device application software. To save time, check the manufacturer's instructions before starting your installation. Initial standalone peripheral installation often still requires a wired connection or network connection. You'll connect the printer to your computer using a cable, then turn on the printer. Frequently used standalone peripheral and printer connections include USB cable connections and wireless connections, including Wi-Fi, Bluetooth, and near-frequency communications, or NFC. And you might encounter 3 other printer connection methods, including a serial port connection, a parallel port connection, or a network connection. Serial connected printers are less common these days. Serial connections transmit data more slowly. RS-232, a recommended standard protocol, remains in use. RS-232 data signals can travel longer distances with better noise immunity and compatibility among manufacturers. And RS-232 cables commonly feature 9-pin connections, as shown here, and 2 screws to secure the cable to the device and the computer. Parallel port connections are less common, but do still exist. In many instances, they have been replaced by USB and other connections. Parallel ports can send and receive multiple bits of data simultaneously, processing data faster than serial ports. Parallel port cables feature 25-pin connections and include 2 screws that help keep the cables connected to computers and devices. Peripheral and printer network connections can be wireless using Wi-Fi or wired using an Ethernet connection. Before adding a connection to a network-based peripheral, verify your connectivity. Here's how to connect and install a printer using a serial or parallel port. These instructions also apply to other peripheral devices. If needed, locate and install the driver or software using the manufacturer's instructions. Next, locate the serial port or parallel port on your computer. Serial port cables usually have 9 pins. Parallel ports have 25 pins. Attach the cable connection to the computer's port. These cables include side screws that attach to the computer body so that the cable remains connected to the computer. Power on your printer and configure the printer. Printer connections are available within the Settings app. Using the Settings app, select Devices, Printers, and Scanners, and then select the plus Add a Printer or Scanner option. Windows often automatically detects connected printers. If the printer's software is installed, select Open Printer app to configure the printer. If you don't see the printer that you want to add, select the link for the printer that I want isn't listed. This option is beneficial for older style printers and network-connected printers. Follow the prompts to find a printer using other options, including older printers, network printers, Bluetooth printers, or any printer needing a manual connection. In this video, you learned that printers require software known as drivers for the computer and the printer to be able to communicate with each other. In some instances, to use all the printer's capabilities, you need to install the manufacturer's software. Both serial and parallel port cables include side screws that attach to the computer body so that the cable remains connected to the computer. And to add a network printer, verify your computer's network connection, locate your operating system's printer and scanner settings, and search for an available network printer. Welcome to Installation Types. After watching this video, you will be able to define hardware and software installation, evaluate the advantages of plug-and-play over driver installation, and explain the similarities of IP-based and web configuration. Installation is the process of making hardware and/or software ready for use. Different systems require different types of installations. While certain installations are straightforward and can be performed by non-professionals, others are more complex and may require the involvement of specialists. The types of installation can be broken down into 2 categories: plug-and-play and driver installation. Plug-and-play, sometimes abbreviated as PNP, describes devices that work with a computer system as soon as they are connected. The user does not have to manually install drivers for this device, or even tell the computer that a new device has been added. Examples of PNP devices include mice and keyboards. If a PNP device doesn't function in Windows, the user should look in Device Manager for an indication of a problem with the device. Device Manager is part of the Windows operating system. It allows users to view and control the hardware attached to the computer. When a piece of hardware is not working, that hardware is highlighted with a yellow icon for the user to deal with. One cause of device malfunction is an outdated driver. A driver is the software that allows a device to talk to the operating system. Updating the driver may restore proper function to a device. To update a device driver in Windows 10, follow these steps. First, open Device Manager by typing Device Manager in the search box and selecting Device Manager. A list of names of installed devices will display. Click the arrow to the left of the device you're looking for to expand the list. Right-click the device you'd like to update and select Update Driver. An IP-based peripheral is hardware that is connected to a transmission control protocol, Internet Protocol, or TCP/IP network. Examples of IP-based peripherals are wireless access points, wireless routers, IP security cameras, network print servers, and networked printers or multifunction devices. These devices must be connected to a local area network or LAN or the Internet for installation and functionality. When you install a device, you get it ready for use. But when you configure a device, you're setting it up to work according to your preferences. Web-based configuration is used for networking devices, such as routers. This makes the setup process easier. All your work is done on a web page, which is generally found on the manufacturer's website. In this video, you learned that hardware and software installation is a prerequisite for functionality. One of the advantages of plug-and-play over driver installation is the speed with which a device can be installed. The alternative is to install drivers manually, which is more time-consuming. And IP-based and web-based configuration both require an internet connection for installation and functionality. Welcome to Internal Computer Components. After watching this video, you will be able to recognize several internal computer components, explore the role of a motherboard, and evaluate the importance of data flow. A motherboard is the main printed circuit board or PCB in computers and other expandable systems. Motherboards contain significant subsystems such as the chipsets, input, output, and memory controllers, interface connectors, and other components integrated for general use. Motherboards allow communication among many crucial electronic components, such as the central processing unit or CPU and memory. And motherboards also provide communication pathways for peripherals, such as keyboards and other components. A chipset is a set of electronic components in an integrated circuit that manage data flow among the processor, memory, and peripherals. A chipset has two parts, the north bridge and the south bridge, which manage communications among the CPU and other parts of the motherboard. A north bridge chip, or host bridge, is one of the two chips in the core logic chipset on the motherboard. Unlike the south bridge chip, the north bridge chip connects directly to the CPU via the front side bus and performs high-performance tasks. The south bridge chip, the second chip of the chipset, generally implements slower performance tasks, and a south bridge chip is usually not directly connected to the CPU. A bus is a high-speed internet connection embedded as printed circuits on the motherboard. A bus sends control signals and data among the CPU and other internal components. It's like the information superhighway of the computer. A front-side bus is a computer communication interface that carries data between the CPU and the memory controller hub, or the north bridge. Now, a socket is the array of pins and the securing mechanism that hold a processor in place and connect the processor to the motherboard. Socket pin connections differ depending on which generation of CPU your motherboard supports. Older sockets use a pin grid array, or PGA, that uses short, stiff pins on the CPU that align with the holes on the socket. When installing a CPU, do not force the CPU into the socket. If the CPU and socket are correctly matched, the CPU should fit. Newer motherboard sockets, called land grid arrays, or LGAs, have built-in pins and the CPUs have contact points on them. A power connector is a device found on a motherboard that allows an electronic current to pass through it to provide power to a device. Not all power connectors look alike. An ATX-style connector is one of the larger power connectors inside a computer. These connectors join the power supply to the motherboard. In this video, you learned that internal computer components include everything connected to the motherboard. A motherboard provides a communication pathway for peripherals. Buses send control signals and data between the CPU and other components. Components not directly attached to a motherboard connect via sockets. And sockets are the architecture of pins that allow CPU installation. Welcome to Data Processing and Storage. After watching this video, you will be able to recognize the role of memory in a system, differentiate between memory slots and expansion slots, and evaluate the importance of the BIOS and CMOS. The CPU is a silicon chip in a special socket on the motherboard. CPUs contain billions of microscopic transistors on a single computer chip. These billions of transistors enable the computer calculations needed to run programs available in your system's memory. A 32-bit CPU is a processor architecture that can transfer 32 bits of data per clock cycle. Think of a 32-bit CPU as a two-lane information highway. 32-bit processors are found in laptops, workstations, and servers. A 64-bit CPU is comparable to a four-lane information highway, enabling twice the amount of data to move compared to a 32-bit CPU. 64-bit processors are also found in laptops, workstations, and servers. Random access memory, or RAM, temporarily stores working data and machine code. Because RAM is volatile, any data existing in RAM is lost when power is terminated. RAM is cold pluggable or cold swappable. Cold pluggable or cold swappable means that the hardware is off or that the hardware is in a state of being without power. RAM speeds are measured in megahertz or millions of cycles per second. Currently, RAM speeds can range from 1333 MHz to speeds of 2133 MHz. RAM is available in several forms of varying speeds and storage capacities, depending on your type of motherboard and needs. The memory you use depends on your motherboard type. Common forms of memory include the following. Dynamic Random Access Memory, or DRAM, stores each bit of data in a memory cell, usually consisting of a tiny capacitor and a transistor. SDRAM, or Synchronous Dynamic Random Access Memory, is a form of DRAM semiconductor memory that can run faster than DRAM. Double Data Rate Synchronous Dynamic Random Access Memory, or DDR SDRAM, is faster than SDRAM because it fetches data twice per clock cycle. Double Data Rate 3 Synchronous Dynamic Random Access Memory, known as DDR3 SDRAM, is faster than DDR SDRAM. And Double Data Rate 4th Generation, or DDR4, is a faster, more reliable replacement for DDR3 SDRAM that uses less power. And Small Outline Dual Input Memory Module, or SODIMM, chips are commonly used in notebooks since there is a lack of space. SODIMM slots take half the space of desktop slots, but they draw more power. A memory slot holds a RAM, random access memory stick in place on a computer's motherboard. Only memory chips can fit into these dedicated slots. Memory slots allow the system to use RAM by enabling the motherboard to communicate with memory. And depending on the motherboard, there will be 2 to 4 memory slots, sometimes more on high-end motherboards. The memory slots on the motherboard determine the type of RAM that's compatible with a computer. Older machines used the original Peripheral Component Interconnect, or PCI, expansion slots. Newer motherboards use the PCI Express, known as PCIe. These slots hold expansion cards designed to provide additional features to a computer, such as enhanced sound, memory, high-end graphics, and network interfaces which can be wired or wireless. The computer's motherboard determines which additional capabilities are available based on the additional slots. The disk controller is a circuit that enables the Central Processing Unit, or CPU, to communicate with a hard disk, floppy disk, or other kinds of disk drives. The Integrated Drive Electronics, or IDE disk controller, was a standard created for communications between the CPU and hard drives in computers. An IDE controller exists as a small circuit board on the motherboard with chips that guide how the hard disk drive stores and accesses data. Most controllers include some memory that boosts hard drive performance. The BIOS, Basic Input-Output System, manages your computer's exchange of inputs and outputs, mostly when you're booting up your computer. Every computer has a BIOS pre-programmed into its motherboard. It's different than an operating system that can be installed, uninstalled, and updated long after you've bought the computer. When your computer is unplugged, the BIOS remains operational and relies on a battery for power. Such batteries exist in laptops and desktop PCs, but it's used more frequently in a laptop because laptops are usually unplugged longer than desktop PCs. You can update a BIOS through a process called flashing. To do this, you need the BIOS version number. You can find the BIOS version number in the System Information window. In Windows 10, press the Windows key plus R, type MS-Info32 into the run box, and press Enter. The BIOS version number is displayed in the BIOS version date field. The directions on how to flash the BIOS differ among motherboard manufacturers. So check the manufacturer's website for their procedure and proceed with caution. CMOS is short for complementary metal oxide semiconductor. A CMOS battery is a coin-sized battery similar to a watch battery that is installed on the motherboard to power the CMOS memory chip. The CMOS memory chip stores a computer's hardware settings. Like all batteries, CMOS batteries expire, and when the battery expires, the system clock resets, and you'll need to replace the battery to restore the computer system time, date, and hardware settings. In this video, you learned that internal computer components include everything connected to the motherboard. A motherboard provides a communication pathway for peripherals. A memory slot holds RAM in place on a computer's motherboard. The computer's BIOS is pre-programmed into the motherboard and uses CMOS to store configuration settings. And you can replace the CMOS battery to restore configuration settings. Welcome to Internal Storage. After watching this video, you will be able to describe general hard drive characteristics, identify characteristics of PATA drives, IDE drives, SATA drives, SCSI, and SSD drives, describe the general characteristics of optical drives, and identify expansion slots. Introduced by IBM in 1956, internal hard drives provide non-volatile long-term data storage, fast access time, and fast data transfer rates. Traditional hard drives contain a platter or disk with a magnetic surface where data is stored. The platter rotates on a spindle which controls the speed of the platter's spin. The metallic head floats just above the platter where it can read and write magnetic data. The head is at the end of an actuator arm that positions the head to read or write data on the platter. Together, the spindle, actuator arm, and head are controlled to read and write a specific task on the disk. Data that is read or to be written reaches the drive using a combination of power connectors, data connectors, jumpers, and other technologies that trigger the actuator arm. The actuator arm positions the head to read and write data from the disk. The power connector provides power to the hard drive. The data connector provides the connection to pass input and output to the drive. And in some cases, the drive can be configured with jumpers to enable specific types of settings. Advanced technology attachment hard drives, known as ATA drives, including integrated drive electronics or IDE drives and parallel advanced technology attachment or PATA drives, originated in the 1980s and were popular until about 2003. The early ATA drives processed data at 33 megabits per second. Later, ATA drives processed data at 133 megabits per second. In 2003, Serial Advanced Technology Attachment, or SATA drives, which communicate using a serial cable and bus, advanced data processing to 1.5 gigabits per second, more than 10 times faster than an ATA. Currently, SATA drives can process data at 6 gigabits per second. SATA drives are available in multiple sizes, known as form factors. SATA drives typically spin at 5,400 or 7,200 revolutions per minute, or RPMs, with capacities from 250 gigabytes to over 30 terabytes. SATA drives still dominate today's desktop and laptop market. Each SATA port supports a single drive. Most desktop motherboards have at least 4 SATA ports. Small Computer System Interface, pronounced SCSI hard drives, joined the storage market in 1986. SCSI drives were fast, working at 10,000 or 15,000 rotations per minute, or RPM. At the time, SCSI drives accessed data much faster than standard ATA drives. SCSI drives began to be discontinued around 1994 and are no longer used. Solid-state drives, known as SSDs, which store data on non-volatile flash memory, joined the hard drive market in 1989. SSDs provide significantly more reliability and are faster than traditional drives. SSDs operate at speeds of 10 to 12 gigabytes per second. Speeds vary by manufacturer and form factor, and SSD drive capacity ranges from about 120 gigabytes to 2 terabytes. SSDs cost more than equivalent SATA drives. However, SSDs provide significantly more reliability than traditional platter-style hard disk drives. SSDs are also available as external drives and hybrid hard drives. As part of a hybrid drive configuration, the SSD serves as a cache, and the SATA drive functions as the storage disk. Hybrid drives tend to operate slower than SSD drives. Next, optical drives, which use compact discs, or CDs, and digital versatile discs, known as DVDs, were invented in the 1960s and came to market in 1992. These drives, like SSDs, provide non-volatile storage. Optical drives use low-power laser beams to retrieve and write data, encoding data for storage onto the laser disc in tiny pits arranged in a spiral track on the disc's surface. CDs are suitable for small capacity storage up to 750 megabytes. DVD storage ranges from 4.7 gigabytes to 17.1 gigabytes. CDs and DVDs can be read-only or read-write compatible. CDs are single-sided, but DVDs can be either single or dual-sided. CDs are created using universal read-write formatting. DVD player formatting happens by region. Media providers can encode DVDs to match the players located in the regions where the content is licensed. Blu-ray discs, as media for movies and video games, provide high-resolution and digital surround sound content. Blu-ray discs exist in single-sided formats, from single-layer up to quad-layer, storing 25 gigabytes per layer. Writable Blu-ray discs also exist in triple-layer 100 gigabyte and quad-layer 128 gigabyte formats. These require BDXL-compatible drives for writing and reading. Expansion slots, when available on the motherboard, are locations where you can add additional storage capabilities. In this video, you learned that internal hard drives provide non-volatile long-term data storage, fast access time, and fast data transfer rates. SATA drives still dominate today's desktop and laptop market, providing larger volumes of less expensive data storage. SSDs, comprised of non-volatile flash memory, provide fast data access but are more expensive than traditional SATA drives. Optical drives provide portable non-volatile data storage. And Blu-ray discs meet the demands for high-quality video and audio and can be copyright protected by region. Welcome to Display and Sound Cards. After watching this video, you will be able to Define what a video card does, explore the function of sound cards, and evaluate the use of a MIDI controller. A video card is either an expansion card in an empty slot on the motherboard or a chip built into a system's motherboard. It allows the computer to send graphical information to a video display device, such as a monitor, TV, or projector. A video card is alternatively known as a display adapter, graphics card, video adapter, video board, or video controller. A graphics processing unit, or GPU, is a specialized processor originally designed to accelerate graphics rendering. GPUs can process many pieces of data simultaneously, making them useful for machine learning, video editing, and gaming applications. Although GPUs are normally associated with the realistic graphics found in top-quality video games, several industries rely on their powerful processing capabilities. An audio card is also known as a sound card. It's an integrated circuit that generates an audio signal and sends it to a computer's speakers. The sound card can accept an analog sound, as from a microphone or audio tape, and convert it to digital data that can be stored in an audio file. Conversely, it can accept digitized audio signals, as from an audio file, and convert them to analog signals that can be played on the computer's speakers. On personal computers, the functions of a sound card are usually directly integrated into the motherboard. But for users who desire higher quality audio, a sound card is a separate circuit board that is plugged into the motherboard. A MIDI controller is a simple way to sequence music and play virtual instruments on your PC. It works by sending MIDI, musical instrument digital interface data, to a computer or synthesizer, which then interprets the signal and produces a sound. MIDI controllers are frequently used by musicians. In this video, you learned that video cards, also known as graphics processing units or GPUs, display data. Audio cards process sounds input into the computer and send signals to internal and external speakers. For most users, integrated audio is all that's needed for meetings and listening to podcasts, videos, and music. Dedicated sound cards allow for more than one input, enabling the computer to process musical instrument digital interface, or MIDI, controller input. And musicians use specialized MIDI sound cards to record sounds from digitally enabled musical instruments onto computers and process those sounds as output. Welcome to Network Interface Cards. After watching this video, you will be able to define a Network Interface Card, or NIC, explore the types of NIC, and apply your understanding of how a modem functions. A Network Interface Card, or NIC, is a hardware component without which a computer cannot connect to a network. It is a circuit board installed in a computer that provides a dedicated network connection to the computer. The card receives network signals and translates them into data that the computer displays. Originally, network controllers were available only as expansion cards that could be plugged into a computer port, router, or USB device. A NIC, or Network Interface Card, provides a connection to a network, usually the Internet. Onboard NICs are built into the motherboard, and add-on NICs fit into an open expansion slot on the motherboard. In terms of function, speed, and quality, there's no significant difference between the types of NICs. Wireless NICs rely on an antenna to communicate through radio frequency waves on a Wi-Fi connection. Wired NICs rely on an input jack and a wired LAN technology, such as fast Ethernet. On a basic level, your modem gives you access to the Internet. From Wi-Fi routers to mobile devices, the components that make up your home network all speak different digital languages, but your modem is the translator. It translates the signals coming from your Internet Service Provider, or ISP, into an Internet connection for your Wi-Fi router to broadcast. The modem receives information from your ISP through the phone lines, optical fiber, or coaxial cable in your home, depending on your service provider, and converts it into a digital signal. Your router and ISP can't communicate directly because they speak different languages, or rather, they transmit different signal types. So the modem digitizes those signals and sends the now usable signals to the router. Before you know it, you're online. In this video, you learned that a network interface card, or NIC, is a hardware component that can be built in or added to a motherboard. A NIC connects a system to a network, often the internet. NICs can be wired or wireless. On-board network cards are built into the motherboard, whereas add-on cards are placed into an expansion slot on the motherboard. And a modem transforms digital information from your computer into analog signals that can be transmitted to a network, and it translates incoming analog signals back into digital data that your computer can understand. Welcome to Cooling and Fans. After watching this video, you will be able to define system cooling, explore the methods of cooling a computer system, and evaluate the effectiveness of liquid cooling. Computers generate heat. Excessive heat can damage internal components. You should never operate a computer without ensuring there is a proper cooling system, air or liquid, installed. Central Processing Unit or CPU coolers are designed to dissipate heat produced by the processor that sits at the heart of your PC. The fans, radiators, and other elements in these cooling components allow the accumulated heat energy to flow away from vital internal parts. There are many cooling methods available. Passive cooling slows the speed at which a component, such as the processor, is operating. This approach contrasts with active cooling, which involves using powered fans instead. Fans in the computer case draw cool air through front vents and expel warm air through the back. In this process, the fans are used to dissipate warm air from delicate internal components. In forced convection, the hot air around an object, such as the Central Processing Unit or CPU, is moved away by a fan blowing air across a heatsink. Thermal paste and a base plate rest between the water block and CPU to help improve the heat transfer properties. One approach to system cooling is to use a heat sink. First, add a heat sink compound to fill gaps between the CPU or Central Processing Unit and other heat-generating components and the mechanical heat sink. Then place the heat sink, which is a passive component made of a conductive metal, over the CPU. Now excess heat is drawn from the CPU through the heatsink to its fins, where a fan blows air to dissipate the excess heat. This method dissipates warm air before it can harm components inside the computer. Liquid cooling works very much like a radiator in your car or home. It's quieter and more efficient than using fans to cool your system. Liquid cooling circulates liquid through water blocks, which rest on top of the chip that is being cooled. The relatively cooler liquid circulating through the water block pulls the heat away from the chip, cooling it. The heated fluid is pumped to the radiator where fans expose it to cold air. The re-cooled fluid is then returned to the water block to be heated, and the cycle repeats. Sometimes liquid cooling is a necessity. PCs used for high-end gaming and places where the ambient temperature is high require augmented cooling measures. Liquid-based cooling methods help in these cases. In this video, you learned that system cooling refers to one of several methods of keeping the internal components of a computer from overheating. Those methods include use of a heatsink and thermal compound, the transfer of heat away from internal components by convection, the use of fans, and liquid cooling. And liquid cooling is quieter and more efficient than fans, but it costs more and comes with the risk of water leaking inside your computer. Welcome to installing the Microsoft Windows 10 operating system. After watching this video, you will be able to list Windows operating system installation prerequisites and identify Microsoft Windows 10 operating system installation steps. Before you begin the installation process, you'll want to confirm the base Windows operating system is available on the computer's hard drive. You'll also want to connect the computer to an electrical source. Let's get started. First, select the installation language, time and currency format, and keyboard or other input language settings and click Next. Then click Install Now. Skip the activation step by clicking I don't have a product key and click Next. You will need a Windows activation key to receive operating system security updates and bug fixes. Select Windows 10 Pro to include all the operating system features and click Next. Click the checkbox to accept the license terms and click Next. Select Custom Install Windows Only Advanced. This option installs Windows for the first time or removes all previously installed operating systems. Accept the default disk partitioning settings and click Next. Now, you have to wait for this part of the installation process to complete. The computer may restart at the end of this process. Scroll the drop-down list to locate the region where the computer will be used. In this demo, we select the United States as the region and click Yes. Now select your keyboard layout. We'll choose the US keyboard and click Yes. Bypass adding a second keyboard layout and click Skip. Next, you'll choose between setting up Windows for an organization or for personal use. In this video, we'll select Setup for Personal Use and click Next. Now, you can associate a Microsoft account with the computer, but we're going to bypass this step and select Offline Account. Then click Next. Windows will remind you to opt in for a Windows account to access apps and services. For this installation, select Limited Experience to stay offline and click Next. Now type a username that specifies who will use the PC and click Next. Create a password for the user. In this demo, we set password spelled $$W0RD as the password for the account. In real life, however, follow good password practices to create passwords that are not easily guessed. And click Next. You'll type the password again to confirm the password and click Next. But don't worry, if you forget the computer's password, you can recover use of the machine by answering the security questions. Using the drop-down options, create 3 security questions for the account and click Next each time. Now, set the toggle switches to Yes to permit Microsoft capabilities. These capabilities include speech recognition, device location, linking and typing, access to the user's geographic location, diagnostic data, and tailored experiences. Click Accept. Microsoft offers the option to synchronize activity history across devices, such as sharing information between a workstation at the office and a workstation at home. Click Yes to accept this feature. Next, you'll see an opportunity to enable the use of Cortana, Microsoft's digital assistant. You can click Not Now or Accept. After completing the prior installation steps, your workstation will take several minutes to complete the remainder of the steps. Then the workstation will shut down and restart. The next time you access the computer, you'll enter the username and password you specified during installation. And congratulations! After logging back in, you'll see the default Windows 10 desktop. In this video, you learned that before beginning the installation process, confirm that the computer is connected to an electrical power source. During the installation process, you may need to confirm which version of Windows you are installing. By selecting Offline Account, you can bypass associating your Microsoft account with the computer. You'll create a username and password and configure 3 security questions and their answers as part of your setup process. And after installation, you'll need to log in using the username and password you previously specified. Welcome to Microsoft Windows 10 Operating System Configuration. After watching this video, you will be able to describe how to create user accounts and use the Settings app to configure frequently updated operating system settings. Most operating systems allow the configuration of multiple levels of users with specific security settings. These include administrator with full permissions, standard user with most permissions except for system configuration changes, and other users with limited access. In this course, we will assume you have administrator permissions. Depending on the organization's rules, you might want to add one or more additional user accounts that do not include administrator permissions. This task is usually more conveniently completed before delivering the computer to the user. On the Settings window, select Accounts. Follow the on-screen prompts to add additional other users. You can even add users who do not have Microsoft accounts. You'll add the user's name, password, and answers to 3 security questions. Select Next, and the user account is automatically added. You'll want to show your user how to sign into their machine using their ID and password or PIN. Some organizations may have protocols for the user to change their password. Then begin adjusting operating system settings with the user present. As an IT support person, you may prefer to unbox the computer before its delivery to the user. You'll use the Settings app, a central location for many Windows configuration and management tasks, to personalize and customize the computer. One of the fastest ways to access settings is to select the Windows Start button and select the gear icon, which opens the Settings app. The Settings app is also a hub for many user-facing operating system settings. Communication protocols enable computers to communicate with each other, including internet communications, document sharing, and more. Standard protocols include Hypertext Transfer Protocol, or HTTP, which displays web pages, Transmission Control Protocol, known as TCP, a network protocol that enables software applications to communicate with each other, User Data Protocol, or UDP, which helps keep communications from chaining out, kind of like a dropped phone call, Internet Relay Chat, known as IRC, a historical text messaging platform, and communication permissions that allow computer users to talk to each other. The first question almost every user asks is, "Am I connected?" To join a wireless network, first select the wireless icon, then select your wireless network and enter the password. Your mobile devices can also use your computing device's internet connection as a mobile hotspot. Simply select the mobile hotspot icon within your wireless settings, then, on the mobile device, select your PC's mobile hotspot name. In addition, you can set connectivity using the Settings app. Select Network and Internet. Depending on how you opened the Settings app, the left pane may or may not display. Both views enable you to verify the computer's current connection status. To discover new networks, select Show Available Networks. To connect to a different network, select Connect and enter the network security key. Then select Next, and the workstation automatically adds and, if needed, connects to the network. View the status to confirm the workstation's network connection. You can also select the Wi-Fi icon on the taskbar to view current connections and add new connections. Here's how to adjust monitor display settings. Using the Settings app, select System. Scroll the display options to display the screen brightness, scale and layout, and screen orientation. If starting from Settings, select System. On the System window, scroll the left pane and select Sound. Here you can choose your speakers, set the default speaker volume, and set the microphone settings. To add a printer or scanner, on the Settings app window, select Devices. Then select Printers and Scanners, and existing printers and scanners are displayed. If needed, you can select the plus add a printer or scanner, where you'll see additional connection options. Review the time and language settings with your user. Here you can set region, language, and speech settings. If you have a user who wants to use speech recognition, you'll need to set up this capability here in addition to configuring ease of access accessibility settings. On the Settings window, select Ease of Access to configure capabilities that help accommodate the needs of blind, colorblind, low vision, and deaf users who need computing enhancements. In this video, you learned that some organizations may require setting up additional user accounts that do not have administrator capabilities. You can use the Settings app to configure regional preferences, printers, networks, video, audio, accessibility options, and more. And Ease of Access capabilities accommodate the needs of blind, colorblind, low vision, and deaf users. Welcome to Microsoft Windows 10 Management and Performance. After watching this video, you will be able to describe disk configuration and management, explain storage and file and folder management basics, explain how to access the health report, and describe how to locate system maintenance. Preferred disk configurations vary by operating system platform. Windows computers generally use FAT32, NTFS, or HPFS configurations. Linux workstations use ext4, and Mac workstations use HFS+. Storage management goals are about optimizing performance, minimizing data loss, and maximizing disk use. You can quickly access storage management options via Settings and Storage. But remember, always back up your data before changing your disk configuration. Storage management capabilities include viewing storage usage on other drives, changing the storage destination, managing storage spaces, optimizing hard drives, and viewing data backup options. Disk management enables hard drive formatting and partitioning. Here's how. In the Windows taskbar box, type Disk Management and open the Disk Management app. Use the Disk Management app to perform disk formatting, partitioning, compression, and cleanup. To see the rules for how files are indexed, within the Settings app, select Search and select Searching Windows. Here you can set rules for how users find their files and which folders to exclude when users search for files. With the rules set, to search files and folders, open File Explorer. Within File Explorer, the ribbon bar displays commands to perform tasks such as opening, editing, copying, and moving, known as pasting and deleting files. Primarily managed through File Explorer, your hard drive configuration determines the allowable number of files and folders. The average user will not encounter limitations. Now, in the Windows taskbar box, type File Explorer Options to open File Explorer. Here you can set file and folder options to open folders within an existing or in a new window, to use a single-click or a double-click action to open a file, and to display recently accessed files and folders. A user might not need a program, or a program may not be permitted on the user's computer based on company policy. You can select Settings and then Apps, and in the Apps and Features section, locate the program and right-click on the program to select the Uninstall option. Most software originates from online sources, so before downloading software, verify that the website is legitimate. In most instances, to install the software, click the designated .exe file. Windows will request your permission to install the software. Simply follow the manufacturer's installation instructions. Now, Windows manages most operating system software updates automatically. To check the update status, using the Settings app, select Update and Security where you can view your Windows update status. If your user mentions that they're having issues with the system performance, open the Settings app, enter the word Performance, and select Device Performance and Health. When viewing device performance and health, the Health Report displays the status of Windows time service, storage capacity, battery life, and apps and software. If needed, use the Settings app, search for System Maintenance, and select the second option to troubleshoot and help prevent computer problems. Then, follow the on-screen instructions to help maintain the computer. In this video, you learned that Windows computers generally use FAT32, NTFS, or HPFS configurations, while Linux workstations use ext4 and Mac workstations use HFS+. The Disk Management app enables disk formatting, partitioning, compression, and cleanup. You can go to Settings and select Storage to change storage destinations, optimize drives, set access data backup options, and more. And you can use File Explorer to set folder options, such as whether to open folders within an existing or new window, whether to single-click or double-click to open a file, and whether to display recently accessed files for quick access. You also learned that the Health Report displays the status of the Windows time service, storage capacity, battery life, and apps and software. And System Maintenance provides troubleshooting capabilities to help keep your computer running smoothly. Welcome to Managing Files and Folders. After watching this video, you will be able to define files and folders, explore the basic options for files and folders, and evaluate security permissions for files and folders. A computer file is a resource for recording data in a storage device primarily identified by its file name. Just as words can be written to paper, so can data be written to a computer file. A file is created first by writing data into temporary memory or RAM. Saving data involves using permanent storage, usually a hard disk drive. All files are either binary or text in nature. While text files contain only textual data that can be read easily, binary files contain textual and custom binary data. Data in binary form can be interpreted by supporting programs, but will show up as garbled text of ones and zeros in a text editor or word processing program. Files and folders have similar naming rules. Both should be named so the file or folder you want is easy to find. Names should be short but descriptive, 25 characters or less. Avoid using special characters or spaces in a file name. Use capitals and underscores instead of periods, spaces, or slashes. And to make names easier to remember, you can use a date format such as 4-digit year, 2-digit month, and 2-digit day, and/or include a version number. A folder is a container for data written to disk. While drives store files, folders are used to organize those files by creating distinct, logical areas with different security privileges. Folders separate the operating system or OS and application files from user data. Folders also organize user data belonging to different accounts. In Windows, there's no limit to the number of folders within folders or subfolders you can create. A file path is also known as the path name. It's the precise location of a computer, file, device, folder, or web page. For example, C Windows System32 tells the user that the System32 folder is in the Windows folder in the C drive. In Windows, you can choose from these commands: Edit to create an updated file or folder, Save to preserve a copy of the file or folder to disk, Cut to place a file or folder temporarily onto the clipboard, and from there, the file or folder can be copied or moved to a new location. Copy, similar to the Cut command, also places a file or folder temporarily on the clipboard, and from there the file or folder can be copied to a new location. And Move, to place a file or folder in a new location. An extension is the final part of the file name that follows a period. For example, letter.docx. The extension .docx indicates the file letter is a MS Word document. The file extension shows the file type and which applications can be associated with different actions, such as open, edit, and print. In this case, the related application is MS Word. Additional file extensions can be researched using the Internet. To create a file, right-click inside a folder or on the desktop. Select New, and then select the application you want. But you'll have to name the file to complete this brief process. Opening a file is just as simple and quick. Either double-click it or right-click it, select Open With, and select the appropriate application. When you create a file, you'll need to choose where you want to save it, for example, the desktop. To do so, select File, then Save As. Choose the location for the new file, and once you've saved a file to the proper location, just select the Save icon or File, then Save. To open or launch a program, just double-click the icon associated with it. Another option is to select the icon and press Enter. Deleted items are kept in the recycle bin and can be recovered by right-clicking an item in the recycle bin and selecting Restore. A file or folder typically can't be recovered if the recycle bin has been emptied, or if you press Shift+Delete when removing something. There's no recycling for items on flash drives or network shares, although a server administrator might be able to recover those files. To select multiple files and folders, click and drag the mouse to highlight them, press the Control key and select items individually, or press the Shift key and select the first and last file you wish to affect. All files between the first and last selected will become highlighted. To find folders and files, follow these steps. Right-click the Start button and type the item name in the search field, or use Cortana to find matching files, programs, apps, messages, and web pages on your system. Alternatively, you can use Windows Explorer to search by file name, file contents, file date, or size by selecting the folder icon on the taskbar. Windows Explorer, or Explorer, is a tool that you can use to manage your files on OneDrive and your PC. To rename a file or folder, right-click it and select Rename. Do not change the extension unless you mean to do so, as that can render the file inoperable. The File Properties dialog box has options for a file or folder. To access the properties of a file or folder, right-click it and select Properties. The window will give you information about and additional control over a file or folder. For security purposes, files and folders have attributes that can be set to read-only, system, hidden, or archive. Read-only allows you to view but not edit a file or folder. The read-only attribute prevents changes from being saved back to the file. You will be prompted to create another file containing the modified data. The system attribute specifies that the file should not be accessible to ordinary users. A Windows system file is any file with the system attribute turned on. Windows depends upon system files to operate properly. The hidden attribute specifies whether the file is visible in the default view. It is possible to adjust Windows to display hidden files and folders, though. And the archive attribute shows whether a file has been changed since the last backup. Compression, or zipping, saves disk space by reducing the size of an item. Here's how to do it. Right-click the file or folder, select Send To, and then Compressed or Zipped folder. A new zipped folder with the same name is created in the same location. You can use encryption on files and folders for security purposes. Right-click the folder or file you want to encrypt and select Properties. Select Advanced. Under Compress or Encrypt attributes, check the box for Encrypt contents to secure data. Then click OK and click Apply. Setting permissions is another means to control what can be done with a file or folder. To change these permissions, right-click any folder or file and select Properties. Then switch to the Security tab and make your selection. In this video, you learned that files are organized data in a specific format. That data may exist in memory, a permanent storage capacity, or both. Folders are digital containers for files. Folders are used primarily for file storage and organization. Files have numerous extensions that identify the file type and which program or programs can open them. Files and folders have a variety of options to manage them. And files and folders have native encryption options in Windows for security purposes. Welcome to Evaluating Computer Performance and Storage. After watching this video, you will be able to identify the 4 key processor performance criteria, evaluate random access memory known as RAM availability, assess a computer's storage capacity, and evaluate network speeds and identify common connectivity issues. The following 4 components contribute to performance: the processor speed, the number of cores, the bus types and speeds, and the presence of cache. Processor speed, a primary computing measurement, is measured based on electrical clock speed in units of time referred to as hertz. Older devices measured processor speed in megahertz, but today's computing resources measure in gigahertz and even greater speeds. Faster processor speeds usually mean faster task completion. Cores located in the center of the CPU can process data together or separately. While current CPUs can have up to 64 cores, most processors offer between 2 and 8 cores. Core speeds, called clock speeds, are based on the speed the CPU runs internal processes and accesses its cache. Next, processors can have multiple cores. The presence of more than one processor or core on the same physical platform is known as symmetric multiprocessing, or SMP. Multiple cores can process tasks together or independently, and many current personal computers offer 4 or more cores. More cores can equal faster computer performance, but that outcome is task-dependent. Next, buses located on the CPU's perimeter act as the data highway from the processor to the components. Historically, computers had 3 bus types: the address bus, which transports memory addresses from the processor to memory and sends and receives memory address information from the CPU, primary storage, and input-output devices; the data bus, which transports data to and from the processor, the CPU, and input-output devices; and the control bus, which transports control signals from the processor to memory and input-output devices. New technology such as Quick Path Interconnect, PCI and PCI Express, Hypertransport, and others are replacing traditional buses. When available on the CPU, cache memory buffers information and speeds tasks, which can help offset slower processor speeds. Many desktop computers and many laptops support traditional hard disk drives, solid-state drives, portable flash memory, and hybrid hard drives. In this chart, you can see that solid-state drives are the fastest storage option. Hybrid storage drives, new to the market, promise greater capacity while maintaining speed. To evaluate disk storage capacity and availability in Windows 10, on the taskbar, type this PC and press Enter. Then click Open. The window for this PC displays, and within Devices and Drives, view the available disk space. Next, random access memory, known as RAM, provides temporary memory that enables computers to install software, display websites, display files, and process edits for files in memory before those changes are saved to storage. Upgradable on some computers, RAM is currently available in gigabyte increments. When machines run out of RAM, you'll experience screens that freeze or stop working, browser tabs that error and close, out of memory and other on-screen errors, corrupted files, computer beeping sounds, and other errors including the infamous blue screen of death. When RAM errors happen, you'll want to check RAM usage. On Windows 10 computers, in the search box on the taskbar, type Task Manager, select the Performance tab, and view the Memory section. You'll also want to check the computer for hardware failures. In the Windows taskbar search field, type Windows Memory Diagnostic. Follow the prompts to run the diagnostics. When the diagnostic tool runs, hardware-related memory errors, if they exist, are displayed on screen. If indicated, upgrade or replace the RAM. Network speed, known also as throughput rate, is commonly measured in bits per second, although sometimes you will see measurements in bytes per second. Most network processing is measured in megabits per second or gigabits per second. A speed test is one of the fastest ways to determine connectivity. Open a web browser, search for speed test from your internet provider or from a trusted organization, such as Ookla at speedtest.net. Follow the on-screen instructions to test and view your results. What if the machine is not connected to the internet and you want to determine if the machine is connected to a wireless network? Click the wireless icon in the taskbar tray, click Properties to view your wireless network connection, and scroll to the Properties heading and view your link speed. If the computer is connected to the network using an Ethernet cable, you can check its connectivity via Ethernet settings. In the Windows taskbar search box, type Ethernet settings and click Open. Scroll the settings window to the Properties section and view your link speed. In this video, you learned that evaluating processors is a four-part process based on the processor speed, the number of cores, bus types and speeds, and available cache. Determining used and available storage space is a fast process on Windows computers. When evaluating RAM, check its usage and check the computer for hardware errors. An online speed test is a fast network speed assessment method. And a computer's Ethernet settings is a quick method of checking a connected computer's network access and speed. Welcome to Workstation Evaluation and Setup. After watching this video, you will be able to identify the user's computing needs, evaluate computers based on their hardware specifications, and perform basic hardware setup tasks. Let's begin evaluating the user's workstation requirements. First, identify the user's job location. Does the user work on-site at an office, work from home, work mobile from a job site or a client site, or work at multiple locations? Once you know where the user works, what are their workspace conditions? Do they have access to a desk and chair? How many electrical connections are available? What kind of lighting does the workspace have? How will the user secure the computer? And finally, does the user have accessibility needs that require additional hardware? Today's work relies on connectivity. If the job function is highly confidential or is moving large amounts of data, a wired network connection might be required. Most users can use a Wi-Fi connection, but users who are away from an office and need to maintain connectivity will need access to a cellular network. Next, will your user store their data on their local machine, within an on-site network of servers, or using hybrid cloud? Applications have memory and storage requirements. Based on the cumulative number of applications, what are the storage, RAM, connectivity, and backup requirements? To meet company or job requirements, or to accommodate user accessibility requirements, users might need peripheral devices, including additional keyboards, mice, monitors, speakers, headphones, microphones, and scanners, among others. You'll need to know what connection types these peripherals require before shopping for the user's new computer. Desktop units generally provide the most versatile and powerful computing solutions. However, laptops are powerful enough for most tasks, including some big data-related tasks. For users who work for multiple locations or work primarily with cloud-based applications, laptops and two-in-one laptop-tablet combinations often are more appropriate and cost-effective. This table displays some minimum specifications you'll want to keep in mind when shopping for your user's new workstation. In most instances, 16 gigabytes of RAM is adequate. However, power users may need an upgradable solution, and web and cloud-based users may be able to work with a minimum of only 8 gigabytes of RAM. Users who work with big data and graphic-intensive design processes usually need a machine with a more powerful and possibly upgradable GPU and storage, adequate ports and peripheral connections, connectivity options, and the ability to physically secure and lock the computer. Purchasing decisions then weigh four important considerations: user requirements, business requirements, available technology, and the company's budget. After the purchasing decision is made and your user's new workstation arrives, the following 6-step process facilitates successful workstation setup. First, reassess your user's physical environment. Next, follow the instructions to unbox the workstation and any peripherals. Then, follow recommended cable management practices. Connect the workstation and peripherals to the appropriate electrical outlet or a power strip. Recheck the user's ergonomics, and complete the workstation setup by configuring the workstation hardware and software. When you arrive with the new workstation, begin by assessing the user's environment, including the sturdiness of the desk and chair, the availability of work-appropriate lighting, electrical outlet access and outlet amperage, and the ability to physically secure the computer. When unboxing, read the instructions and follow the manufacturer's practices. As you unbox the equipment, move boxes and packing materials into a safe location, out of the user's workspace. A part of environmental safety, cable management also reduces support calls. Here are 3 easy-to-remember practices. Install shorter cable lengths when possible. If you have an extra long cable, loop the cable and use a zip tie to secure the cable into its shorter length. Securely attach and identify each cable as you work, and collect and tie multiple cables together out of the way of the user. Electrical management is about safety for you and your user. Label each electrical cable connected to each computing device for peripherals. Then verify that the electrical connections are away from the user and are accessible for later IT support. Connect power supplies to their assigned wall or power strip location, and remember to note the wall outlet number. New computers often require ergonomic adjustments so that the user can work comfortably. Check the user's foot placement, monitor height, arm placement, shoulder placement, lighting, and cord and cable placement. Next, it's time for workstation setup. Power on the workstation and peripherals. Then set up the user's operating system options, including user logon credentials, keyboard options, monitor resolution, printer connections, sound options, security options, and network connections. Next, select the user's default browser. Uninstall unnecessary software. Install and configure additional productivity software, and if the user requests, modify their desktop productivity pane and set up backup options. In this video, you learned that job needs, location, connectivity, and accessibility are essential user considerations. Ranking user requirements, the company's requirements, current technology offerings, and the company's budget are factors that determine which device is purchased. And workstation setup can be summarized as a 6-step process. Welcome to Screen Captures and Tools. After watching this video, you will be able to describe 3 keyboard commands you can use to create screen captures on a Mac OS computer. Identify 3 keyboard commands you can use to create screen captures on a Windows 10 computer, and name 2 keyboard commands used when capturing screens using a Chromebook. There are 3 ways to capture a screen on a Mac OS computer: Command plus Shift plus 3, Command plus Shift plus 4, and Command plus Shift plus 5. To capture an entire screen, select Command plus Shift plus 3. To capture just part of a screen, select Command plus Shift plus 4. You'll also need to apply a drag and release motion when you've included the screen portion that you wish to capture. Note that these first 2 screen capture options automatically save images in a PNG format to the desktop folder. Options and capabilities for Command plus Shift plus 4 include the following: to create a screenshot with a white border around the window with a bit of a drop shadow, press and release the spacebar and release the mouse or trackpad. To adjust the location of the screen capture area, press and hold the spacebar and drag the capture area to where it's needed. Then release the mouse or trackpad when the screen capture area is in the correct location. To adjust the bottom edge of the capture, hold down the Shift key as you move the bottom edge to the desired location, then release the mouse or trackpad. To capture part of a screen or an entire screen as a photo or video, select Command plus Shift plus 5. The displayed options enable you to select the entire screen, a window, or a part of the screen and capture it as an image or a video. After recording, select the location to save your image or a video capture. Microsoft Windows 10 provides the following screen capture capabilities. To capture an entire screen, select Windows key plus Print Screen. The Windows key may have the Windows logo or say Win, short for Windows. After you use this keyboard shortcut, Windows automatically saves your image in a PNG format to the Pictures/Screenshots folder. To capture only your active window, select Alt plus Print Screen. The screen capture exists on the clipboard. Next, open an image editor to view and save the image. The default screen image format is PNG. For more screen capture options, select Windows key plus Shift plus S. This keyboard shortcut opens the Snip and Sketch tool. The displayed options enable you to select the entire screen, a part of the screen, or your active window. To capture an entire screen, select Control plus Show Windows. Note that the Show Windows key looks like a rectangle with two lines on the right side. To capture a partial screen using the keyboard, select Control plus Shift plus Show Windows. Click and drag the crosshair icon until the part of the screen you want to capture is highlighted, then release the mouse or trackpad. Note that each of these screen capture methods saves your image in a PNG format. Depending on the installed Chrome operating system version, your image might display in a pop-up window. Clicking on the notification will open the Chrome OS Files app. But if you don't see your image display, all screenshots are saved as PNG files and stored in the Downloads or Google Drive folder. In this video, you learned that each operating system platform provides full and partial screen capturing capabilities through keyboard commands. The default image file format for all three platforms is a PNG file format. And the OSs differ in how they save screen captures. Mac OS saves images by default to the desktop. Windows 10 automatically saves images to the Screenshots folder. And Chrome saves images in the Downloads folder or to the online Google Drive of the logged-in account holder. Welcome to Introduction to Troubleshooting. After watching this video, you will be able to describe basic computer support concepts, describe troubleshooting procedures, leverage sources of support, and summarize the CompTIA troubleshooting model. Effective computer support involves three basic concepts: determining the problem, examining the problem, and solving the problem. It's hard to fix something if you don't know what's wrong, so you first need to determine the problem. Ask users questions and discover if the hardware or software has been changed in any way. Next, try to reproduce the problem and note symptoms. If there is more than one problem, then you should address each problem separately. Do not let yourself get overwhelmed or off track. Do what you can to collect information about the reported problem, including common symptoms. Once you've determined the problem, examine it more closely. The better you understand the problem, the easier it will be to choose the best solution. Here are some tips for examining the problem. Consider the simplest explanations, such as improper settings or even incorrect use of the hardware or software. For example, the source of the problem may be as simple as the power cord being unplugged. Consider all the possible causes of the problem and address them one at a time. Try different troubleshooting methods until you find one that works. And once you have a theory, test it. And if necessary, bring the problem to a higher level support person or another department. Okay, now that you are familiar with the problem, you can solve it. At this stage, you should create a plan for addressing the problem and document the process for carrying it out. Documentation will help you track the steps that you follow and how effective they are. Once you have decided if you will solve the problem by repair, replacement, or both, carry out the solution. Let your documentation guide you so that you do not repeat steps. Record each step you take and include the results it produces. After you've carried out your solution, confirm that the system is fully operational, then update your documentation. Troubleshooting is a systematic approach to problem solving that is often used to find and correct issues with computers. The first step in troubleshooting is gathering information about the problem. Identify any undesired behavior or lack of expected functionality. Other steps in the troubleshooting process include duplicating the problem, triaging the problem, identifying symptoms, researching an online knowledge base, establishing a plan of action, evaluating a theory and solutions, implementing the solution, and verifying system functionality. To restore functionality, check the following. Check for signs of activity such as LEDs, the power light, and the typical sounds computers make when running. Check for the cause of 2 or more beeps. This step requires using the internet. Check the monitor controls and power if the screen is dark. And check connections on peripheral devices. Many issues occur regularly on a personal computer. Some examples include the following: loose cables or connections, power issues, physical damage, boot-up problems at the BIOS level, or during the power-on system test, or POST. POST is a program which runs on startup and verifies that everything the computer needs to properly boot up is there. Blue or black screen, operating system or OS problems, and software errors. Fortunately, many of these problems have simple solutions that you can quickly implement. If you need additional support, consider consulting the internet. A search engine such as Google, Bing, or DuckDuckGo can be an invaluable tool in your tech support kit. You can also look for online support such as driver downloads, as well as technical support community groups. Often, manufacturer-provided documentation is also available online. If you cannot find the help you need online, consider contacting the manufacturer's technical support. You can often find the contact information in the computer's manual. Before contacting support, ensure you have all documentation on the machine. You will likely be asked to provide them with the name of the hardware or software currently experiencing the problem, the device model and serial number, the date of purchase, and an explanation of the problem. The industry standard troubleshooting model comes from the Computing Technology Industry Association, or CompTIA. The CompTIA model includes the following steps. Identify the problem. In this step, you gather information, duplicate the problem if possible, question users, identify symptoms, determine if anything has changed, and approach multiple problems individually. Research the knowledge base or internet if applicable. Establish a theory of probable cause. In this step, you question the obvious, consider multiple approaches, and divide and conquer. Test the theory to determine the cause. Once the theory is confirmed, determine the next steps to resolve the problem. Or, if the theory is not confirmed, establish a new theory or escalate the problem. Establish a plan of action to resolve the problem and identify potential effects. Implement the solution or escalate as necessary. Verify full system functionality and, if applicable, implement preventative measures. And finally, document findings or lessons learned, as well as actions and outcomes. In this video, you learned that computer support concepts are specific and sequential. Troubleshooting procedures often begin with looking for common problems. Sources of support include online resources and the manufacturer's technical support. And the Computing Technology Industry Association, or CompTIA, has the industry standard troubleshooting model. Welcome to Advanced Microsoft Windows 10 Management and Utilities. After watching this video, you will be able to describe essential workstation management tasks, describe the purpose of drivers and how to update them, and identify 5 useful Windows utilities. Policy management applies rules for passwords, password retries, allowed programs, and other settings specific to the machine or group. Here's how to access policy management. Type Group Policy in the taskbar search box. The Edit Group Policy control panel option displays. Click Open. Select the user configuration settings to view its details and edit policy settings. Windows automatically schedules processes and allocates resources most of the time uneventfully. Sometimes, though, a task might stall and you need to end the task and stop the process. Open Windows Task Manager to view apps and their background processes. When you locate the troublesome software or process, select End Task to stop the process. Perhaps you want to verify the installation and performance of a new hard drive, or that the computer recognizes memory, or recognizes another computer component, such as an add-on card, which includes interfaces. In the Windows taskbar field, type Device Manager. Select Open to launch the Device Manager app. Scroll the list and you'll see the computer's hardware, components, and interfaces, such as the Intel Management Engine Interface number 1. Double-click to view the interface's properties. Here, on the General tab, you can confirm that the interface is working properly. You can also view events, evaluate resources, set power management options, update driver software, which works with the computer for external capabilities, update firmware, which is onboard device software, and view additional device details. Windows uses RAM for frequent memory tasks and virtual memory for less frequent tasks. If the computer's performance is slow or the computer is displaying low on virtual memory errors, it's time to take action. To evaluate memory performance based on the installed RAM hardware, open Task Manager and view the memory resource usage. If needed, run the Windows Memory Diagnostic. Sometimes an installed program needs more virtual memory. To manage virtual memory, select Settings and About, then begin typing the word Performance. Select the option to adjust the appearance and performance of Windows. The Performance Options window displays. In the Virtual Memory section, select Change. In most instances, Windows automatically adjusts virtual memory. If you do find that you need to adjust virtual memory, such as for a memory-intensive application, this is the Windows operating system location where you can adjust those settings. Service Management automatically handles background tasks. However, sometimes a program just won't close, or perhaps you see a program using so much memory that other programs can't run. Service Management enables you to troubleshoot and manage these situations. Capabilities include stopping the service, restarting the service, running a program, taking no action, and restarting the computer. Drivers are software components that enable communications between the operating system and the device. If a device suddenly stops working aside from a power issue or other hardware issue, it's possible that the driver is outdated. Perhaps a printer suddenly stopped working because the printer needs a new driver to communicate with the computer. To update or configure a new driver, access Windows Device Manager, locate your device and right-click to view the device's details. If needed, select Update Driver. Utilities help you administer and manage the operating system. Windows Diagnostics locates hardware memory errors. Windows Performance Monitor provides performance details for processes, applications, and hardware. Windows Event Viewer provides detailed activity logs to diagnose errors, installation problems, and other issues. Windows Registry Editor enables the correction of embedded software registration information, such as the disk location for a program's files. And Windows Task Manager enables the viewing and management of machine tasks that help you troubleshoot errors and enhance performance. In this video, you learned that policy management decisions enhance security. You can use Windows Task Manager to view apps and their background processes and select End Task to stop software processes. Windows Device Manager helps you verify that computer devices, components, and interfaces are working correctly. Service management automatically manages background tasks and enables advanced troubleshooting of performance issues. And 5 useful Windows utilities include Memory Diagnostics, Performance Manager, Event Viewer, Registry Editor, and Task Manager. Welcome to Introduction to Business Continuity Principles. After watching this video, you will be able to describe the importance of business continuity, evaluate a fault-tolerant system, and explain the importance of disaster recovery plans. In today's technology-reliant world, you must understand some basic risk management strategies to deal with disruptions so productivity issues are minimized. That's where something known as business continuity comes in. Business continuity is having a plan to deal with difficult situations so an organization can continue to function with as little disruption as possible. Whether it's a business or charity, all organizations must know how they can keep going under any circumstances. Business continuity is built upon fault tolerance. That's the ability of a system to continue operating without interruption when one or more of its components fail. Fault tolerance anticipates disruption and develops contingency plans. Fault tolerance designs systems without single points of failure, so if one part of a system goes down, it doesn't take down the entire system. The cost of a system outage is a crucial consideration of a business continuity plan. So is having a strategy to minimize the effects of system outages. This is known as redundancy. The broad categories of redundancy include system, network, and hardware. System redundancy augments the fault tolerance levels of the existing system. Network redundancy allows data to be rerouted to an alternate path until all systems are functional. And hardware redundancy serves as a solution to a disabled server. Redundancy, or replication, refers to the additional capacity of a computer network above what is needed for normal operation in the case of an outage or other disruption of operation. Think of it as a safety net for the almost inevitable system or component failure. It's having a backup system at the ready. There are 5 common types of redundancy. The first type of redundancy is data redundancy. It's implemented through backups. Data redundancy occurs when the same piece of data exists in multiple places. Unfortunately, data redundancy can cause data inconsistency, which can provide a company with unreliable and/or meaningless information. One example of this is to have multiple versions of the same file on a network. As such, real-time syncing of the data across all its backups is vital for all copies to be consistent with one another. The next type of redundancy is known as Redundant Array of Independent Disks, or RAID. RAID has 3 varieties and provides server hardware failover redundancy. RAID 0 allows a storage system to tolerate individual disk unit failures, as the data is simultaneously written to more than one disk. In a RAID 1 system, there's an exact copy or mirror of a set of data on 2 or more disks. And in a RAID 5 group, there are a minimum of 3 hard disk drives, or HDDs, and no maximum. RAID 5 is considered one of the most secure RAID configurations. Network redundancy is the process of adding additional network devices and lines of communication to help ensure network availability and decrease the risk of failure. Some of the features of network redundancy are multiple adapter cards and/or ports for individual hosts, and load balancing, in which a networking solution is used to distribute traffic across multiple servers in a server farm. There are multiple network paths between nodes, and routers can detect failed links and choose to reroute data by finding alternate paths for it. Site redundancy is the ability to lose an entire site without losing signaling or application state data. It guards against total loss of operations due to a natural disaster or major network failure. This type of redundancy employs the process of replication to synchronize data among multiple sites and ensures data access. And power redundancy is having two independent power sources. If one power source has an interruption, the other source activates. This eliminates downtime from the loss of the primary power source. One way to augment a power redundancy scheme is to use an uninterruptible power supply, or UPS. A UPS adds a layer of protection if something as expensive as a backup power generator is not feasible. The point of backups is to create a copy of data that a business can restore from when a primary copy is damaged or unavailable, and have a specific and sequential strategy for backups that identifies key backup concerns and selects appropriate backup types based on needs and resources. Backups restore data. Backup methods include the following: full, which creates copies of all files; incremental, which copies only those files that have been altered since the last full backup; differential, which saves only the difference in the data since the last full backup; and daily, which keeps a backup of just those files that have been modified the same day the backup is done. A backup storage device is used to make copies of data that is actively in use. Backup media provide redundancy of data residing on primary storage. Should the primary storage medium, such as a hard disk drive or HDD, fail or become corrupted, the original data can be recovered from copies on the backup hardware. Examples of backup devices include a USB drive, an external hard drive, a local area network or LAN, and tape. A backup strategy must balance these considerations. Costs: you may have to buy hardware and software, pay for a maintenance agreement, and train your staff, and location. Many businesses back up to the cloud, but consider keeping a copy of your data in an additional location too, as cloud outages do happen. Businesses need to know the requirements of each backup approach in storage, cost, and time. These factors impact the length of the backup procedure and the recovery. Disaster recovery is an organization's strategy for restoring functionality to its IT infrastructure. This plan must explain the actions to be taken after a disaster. It involves strategies for specific scenarios to ensure continuity. A swift recovery depends on plans that are specific, imaginative, and comprehensive. And the choice of disaster recovery methods depends upon needs and resources. In this video, you learned that business continuity in the wake of unexpected outages relies heavily on planning. Fault-tolerant systems can continue operation despite outages. The choice of redundancy option and backup system depend on a business's needs and resources. And disaster recovery plans aim to resume operational functionality to a business after an outage. Welcome to the IBM Technical Support Professional Certificate. Did you know that industries worldwide depend more on technology now than ever before? That's because more people are using technology in their everyday lives, including working remotely, taking online classes, and even having health checkups with a doctor via webcam. With a worldwide increase in demand for technology comes an increase in need for user support for all technology-related needs. Who will provide technical support to individuals, companies, and organizations? Professionals who are knowledgeable in the fundamentals of computer hardware, operating systems, software, networking, storage, cybersecurity, and cloud computing. According to the most recent U.S. Bureau of Labor Statistics report, about 70,400 computer support jobs are posted annually in the U.S. alone, and job growth in the computer support industry is projected to increase 9% through 2030. At the time of this course publication, the median U.S. computer support specialist salary is $57,910 US annually, and per hour pay is almost $28 US. Technical support jobs are also a great way to start on your path to a high-paying career in information technology. This certificate consists of several engaging and informative courses designed to introduce you to the fundamentals of technical support as well as information technology fundamentals. Additionally, this professional certificate can help you prepare for the CompTIA IT Fundamentals Certification exam. This is a beginner-level certificate, which means that anyone, even if you're new to IT, can take this course. You don't need prior experience in IT or technical support. No college degree is required. All you need to get started with this certificate is a willingness to learn and a basic computer literacy to take online courses through your web browser or mobile app. The courses in this certificate will introduce you to the essential parts of IT. You will learn about hardware, software, networking and cybersecurity, cloud computing, ticketing systems, and careers and pathways in IT. Throughout the courses, you'll hear from IT insiders as they share their experiences and what they've learned as they've progressed through their careers. Some of the experts you'll hear from are Aditya Pundir, an IT manager, Michelle Sanchez, an instructional designer who started in help desk, Mike Schwartz, who works in IT support, and Amy Taylor, an enterprise support technician. You will learn in this course through guided instructional videos that walk you through key concepts with essential need-to-know facts. Interactive exercises will reinforce what you've learned in videos. Insider viewpoints allow you to learn from professionals working in many fields of IT. And practice assessments and graded assessments will help you gauge your knowledge and prove what you've learned. Upon completing all of the courses, you'll earn a shareable badge and the IBM Technical Support Professional Certificate. Why do you need a professional certificate? A professional certificate is beneficial for you because it's proof of your knowledge and accomplishments. The IBM Technical Support Professional Certificate has been specifically created to focus on the core knowledge you will need to possess to succeed in technical support and beyond. The courses work together to familiarize you with the elements of IT, introduce you to hardware and software, help you build your IT skills, and provide you with hands-on labs to practice using what you've learned in the course. When you've completed the courses in the certificate, you will receive a professional certificate so that you can share your hard work and accomplishment with potential employers and your professional network. One of the many benefits of the IBM Technical Support Professional Certificate is that all of the courses are online and ready to start when you're ready to take them. The courses have flexible schedules, meaning you can complete the course at whatever time is most convenient for you and at your own pace, even if you have only 2 to 3 hours a week to spare. Or you could even complete the entire professional certificate in as little as 3 months if you spend 5 or more hours per week on the courses. Financial aid is available for those who qualify. So, if you are not sure this program is right for you, you can try a free 7-day trial or you can audit the courses. These options give you the opportunity to sample the content and determine if the courses are right for you. And remember that we're here for your success. If you have any questions about the courses or the professional certificate, just ask. So, what are you waiting for? Let's get started. Welcome to the IBM Technical Support Professional Certificate Overview of Courses. This certificate includes introductory courses on technical support, hardware and operating systems, software, programming and databases, networking and storage, cybersecurity essentials, and cloud computing. The certificate also includes the final course, Technical Support Case Studies and Capstone, to apply your knowledge and skills. The course, Introduction to Technical Support, describes many support essentials, including the roles and responsibilities of technical support professionals, career pathways and progressions in information technology or IT, support tools, ticketing systems, technical skills, and soft skills, all of which are needed to succeed in IT support. In Introduction to Hardware and Operating Systems, you'll learn about internal hardware computer components, including motherboard components, central processing units or CPUs, hard drives, and expansion slots. You'll also learn the essentials of basic workstation setup, commonly used operating system settings, screen capture commands, and effective troubleshooting practices. In the Introduction to Software Programming and Databases course, you'll learn about software, web browsers, software development, programming languages, and database management. In Introduction to Networking and Storage, you'll learn how to diagnose and repair basic networking and security problems. You'll also learn about network types and standards, wired and wireless connections, and common network storage and network sharing options. In Introduction to Cybersecurity Essentials, you'll learn about the fundamentals of cybersecurity. You'll also learn how to recognize common security threats and risks, examine the characteristics of cyber attacks, and explore methods for securing and managing confidential information. In the course Introduction to Cloud Computing, you'll discover the many elements of cloud computing and how cloud computing is changing the world of technology. You will identify various cloud service models, deployment models, and key components of cloud infrastructure. You'll also learn about cloud security, monitoring, emerging trends, and job roles in the cloud industry. And finally, in the technical support case studies and capstone, you will apply your knowledge and skills to practical IT support scenarios. You will also complete a final exam designed to prepare you for the CompTIA IT Fundamentals Certification exam. Are you ready to begin your journey toward becoming a technical support professional? Start on your first course today. Welcome to Exploring Linux Operating System Essentials. After watching this video, you will be able to explain why companies adopt Linux, describe how to create a local system account and confirm its settings, explain how to view system information, describe how to use the Ubuntu file system, and explain how to monitor system performance. As an open-source operating system, multiple vendors offer Linux operating system, or OS, versions. Some OS versions include user-friendly graphical user interfaces similar to Windows, while others focus on command line interfaces and capabilities. But no matter which vendor or version, Linux is often the operating system that organizations and their programmers prefer because of its stability, security, and efficiency. Linux versions are known as distributions, or distros. Popular vendors include Debian, Red Hat, Linux Mint, Ubuntu, OpenSUSE, and others. Canonical distributes Ubuntu, a Linux version with a lightweight, easy-to-use graphical interface, and Canonical reports more than 40 million users as of 2021, making Ubuntu's graphic interface a widespread Linux distribution. Linux is available pre-installed on servers and laptops, but you can also download a base Linux operating system and install the system to the workstation using a thumb drive, CD, or network drive. And after you connect to the web to finish your installation, you can complete your workstation setup. Let's begin with an installed version of Ubuntu. To set up a local account, you need to first log in as the administrator. Next, you'll create a local system account that doesn't have administrative rights. Local accounts are typically shared with computer users and do not permit administrative rights. Next, click Activities, and in the search bar, begin typing the word User and then select Settings. In the Settings pane, select Users and then select Unlock. Type the administrator password. Next, you'll add the user's local account information. In the Users window, select Add User. In the Add User dialog box, select the Standard tab, type the user's full name and username. In this example, you see the new user shown as New User 1. Select the Allow User to Set a Password when they next log in option and click Add. Next, locate the Power Off Logout option. Click the expander arrow and select Switch User. Select New User 1. Now type the new password, ChangeMe! 234, and press Enter. Again, click Activities. Then, in the search bar, type the word User and select Settings. Select Users in the Settings pane, then select the New User 1 tab to confirm the account information. And you'll see the user's account settings below the user's name. Next, let's learn how to locate system hardware and operating system information. You can quickly locate system hardware and operating system information, including the operating system version and build number. Here's how. Select Activities. In the search bar, type About and press Enter. Then click the Settings option, About, View information about your system. You'll see the device name, hardware module, memory, processor graphics card, disk capacity, OS name, OS type, genome version, windowing system, virtualization, and software update status. Let's now quickly access folders and files by selecting either the Files icon in the left navigation pane or the Home folder on the desktop. On the home screen, you'll see an easy-to-navigate familiar folder structure. This file structure includes pre-configured folders for desktop, documents, music, pictures, templates, videos, and other categories of files. To create a new folder, on the home screen, within Folders, right-click and select New Folder. And name the new folder Test Folder 1, for example. Next, double-click Test Folder 1 to view its contents. In this empty folder, let's create a file. Select the LibreOffice document icon and a document opens. Add some text to the file, for example, test:creating a file. Select File and Save or Save As. Then select the destination folder and save this new file in that folder. Now close the document. Finally, confirm that your file is in the correct folder. On the home screen, double-click Test Folder 1 and you'll see the test1.odt file. Next, let's look at where you can find system performance information. To monitor system performance, view the Activities screen and click Activities. Within the search bar, type System and select the System Monitor app. The System Monitor app provides essential CPU, RAM, disk, and priority performance information to help you troubleshoot performance-related issues such as applications that stall or lag. The app organizes this information in the Processes, Resources, and File Systems tabs. In this video, you learned that organizations adopt Linux because of its stability, safety, and efficiency. You first log in as an administrator to create user accounts, and you can set a user account so that the assigned user sets their password the first time they use the workstation. You also learned that you can select About and click About View information about your system to view your computer's name, memory, installed version of Ubuntu, as well as verifying operating system updates and more. To locate files and subfolders, select the Folders icon within the left navigation pane on the home screen. And finally, the System Monitor app organizes system performance information in the Processes, Resources, and File Systems tabs. Welcome to Getting Started with Mac OS. After watching this video, you will be able to explain why companies invest in Mac OS computers, list Mac OS setup steps, describe Mac OS desktop features, describe how to view users, update user settings, and add and remove users, and explain how to use the Finder for folder and file management. So, why do companies invest in Mac OS computers? Apple pre-installs Mac OS, providing users with simplified setup and migration. Built on Unix, Mac OS computers can also run Linux in dual mode or as a virtual machine. And Mac users are less likely to need on-site help desk support, reducing support costs. Apple's rigorous application testing process is built for both security and ease of use. Mac OS applications include business productivity vendors such as Microsoft, Adobe, Slack, and many others. And Apple provides online help and in-person support at the Apple Store and designated vendors. Organizations, including IBM, report lower total ownership costs after factoring in hardware, software, security, and support costs. Users reported improved ease of use, and organizations, including IBM, have reported significant worker productivity gains. So let's get started and explore Mac OS. The initial Mac setup process provides a guided walkthrough excluding data migration. This process takes about 15 minutes, but options and timing can change with each new operating system release. First, specify the computer's displayed language, country, or region. You can optionally configure vision, motor skills, hearing, and cognitive accessibility settings. Then it's time to configure your network access. Next, accept Apple's mandatory data and privacy terms. When migrating from one Mac to another, you can transfer your apps and data to the new machine. When migrating from a Microsoft Windows machine to a Mac, you can bring your data. You'll create a new Apple account or log in with an existing Apple account. An Apple account is required for machine setup and email, App Store purchases, and cloud backups. Next, opt in for machine usage analytics. Then enable Apple's assistant, Siri. If you didn't already, set up Apple Pay. Then set up a Touch ID and create your first user account, which includes administrative machine rights. And finally, allow location services. With this initial setup complete, let's explore the desktop. The dock is where you find applications. You can keep frequently used applications attached to the dock. Next is the contextual menu at the top of the screen, which displays the active application's menu options. For example, with the Safari web browser open, you'll see that application's menu. You'll also see the logged-in user's name, the battery level indicator, the spotlight search, and frequently adjusted options, including screen brightness, speaker volume levels, Siri, and date and time information. The desktop is the area between the menu bar and the dock. You can locate applications using the Launchpad and open the application for use on the desktop. Next, user management is one of the first post-setup tasks. You need to determine who can use the machine and install software on the computer. Here's how. Open System Preferences and type User in the search bar. Then select Users and Groups. You can view all computer users at a glance. Click the lock icon and enter your password to open the lock, to add or remove users, configure user capabilities, change user passwords, and allow users to reset their password using their Apple account ID. When adding a new user, you can create an account with administrator rights or a standard account. Type the user's full name, name the user account, create the password and its hint, and click Create User. Click the key icon to enable automatic password generation. Mac OS can generate passwords with letters and numbers, numbers only, random characters, and U.S. federal government compliant passwords. To remove users, confirm that the lock icon is unlocked. Select the user, click the minus symbol, decide whether to keep or remove the user's data located in the Home folder, click Delete User, and click the lock again to close the lock and prevent unintended changes. Next, let's learn about Mac OS file management. You can use the Finder to locate, move, store files locally and in the cloud, and show and hide folders. Start by clicking the Finder icon displayed in the dock. The left pane displays available top-level folders and the iCloud remote storage location. You can see your files in the central pane. Within the Finder, you can view files by list, icon, or gallery, and provide other options such as grouping files by kind. macOS supports dragging files from one location to another. If a user asks, "Why can't I see my files and folders?" try these steps. Click Finder, and then click Preferences. Now click the sidebar icon. To display folders on the sidebar, select the checkboxes. To remove these folders from the sidebar view, clear the checkboxes. Next, check the settings within Preferences and the General icon. These settings also control which storage locations are visible and the location a user sees first when searching for a file. To display data sources on the desktop, select the Data Sources checkbox. You can also specify the data storage location displayed when a user opens the Finder, and choose whether to open folders in tabs or new windows. A user might also ask, why do I see these warnings before I empty the trash? Or why are my files and folders missing? To help answer these questions, look within the Finder preferences and click the Advanced icon. Select checkboxes to receive a warning before changing a file extension, removing a file from an iCloud drive, and emptying the trash folder. You can also set default folder view options and search locations. In this video, you learned that companies appreciate Mac OS's easy migration, user satisfaction, and reduced support costs, which result in lower total cost of ownership. During Mac OS setup, a user creates an Apple account for email, cloud storage, and purchases, and creates a separate user account for computer access and management. You can manage users, their passwords, and machine permissions within users and groups. You can use the Finder to access folders and files. And finally, if folders or files are not visible, open Finder preferences and adjust the general, sidebar, and advanced settings. Welcome to Networking and Performance Mac OS Essentials. After watching this video, you will be able to explain how to locate system-level hardware, network, and software information, update the computer's network connection, and use the activity monitor to evaluate system performance. Here's how to locate and connect to new wireless networks. Within System Preferences, begin typing the word Wi-Fi. Apple uses predictive text, so you should quickly see the word Wi-Fi. Then select the Network app. Select an available network and enter the network password. After you enter the password, you'll be able to click Join. Optionally, you can display the network password while typing, and you can choose to have the computer remember the network for automatic login when you're near this network. Next, let's learn how to view system information. To view system information, click the Apple logo and select About This Mac. You'll first see the Overview tab. Here, you can quickly identify the Mac OS version, the MacBook model, processor, installed memory, graphics type, and the computer's serial number. Select Software Update to determine if the operating system files are current. You can opt in for automatic operating system updates. Next, select the Displays tab to view basic display information. Select Displays Preferences, and you can adjust the resolution, brightness, color profile, universal control, and night shift settings. Now, let's view the Storage tab. You'll first see an overview of the onboard storage. Click Manage to see an overview of what's being stored, view iCloud storage options, optimize storage, empty the trash automatically, and review and remove files that are no longer needed. So, now that you've seen the overview information, it's time to select System Report. The System Report provides a detailed look at the system's hardware, networking, and software. You'll first see the default hardware view that includes the computer's model name, identifier, processor name, speed, cores, RAM, serial number, and additional essential information for support. You can expand the view and click any of the items, such as Power. Click Network and let's check out the Wi-Fi information. You'll first see the system networking hardware-related information, including the machine's MAC address. Then view information about wireless networks and other network-specific details as you scroll the page. Okay, next let's check out the Software category. Select Software and review the System Software Overview. You'll see operating system version information, the computer's name, the logged-in user's name, and the time elapsed since the computer's most recent restart. And next, within Software, select Applications. Here, you can view application names, versions, sources, dates last modified, and software kind or type, such as if the application is a universal app for all Mac devices. Next, let's check out the Support tab. Select the Support tab and use the displayed information to find out if the machine is still in warranty, find service locations, and obtain help via chat and phone support. Next is the About This Mac Resources tab. Here you'll find links to online documentation and support for the Mac OS operating system and Mac hardware. So next, let's explore the Finder for folders and files. Use the Activity Monitor app to monitor system performance. Press the Command key and spacebar to display the spotlight. Then type Activity Monitor in the search bar and click the Activity Monitor icon to open the app. You'll first see the CPU tab, where you can identify which applications and processes are using CPU resources, what percentage of the CPU's capacity is in use for each application, how much of the total CPU power is in use, and how much of the total CPU power is idle. Next, on the Memory tab, you can see the amount of memory each application is using, the total physical memory installed, how much total memory is in use, the number of cached files, the amount of memory used by apps in total, and the wired memory, or the memory needed for the machine to run. When you view the Energy tab, you'll be able to determine how much energy each application is using and whether the application is using the graphics card, the type of graphics card installed, the amount of battery charge available in both percentage of battery and time formats, and the most recent amount of time on battery. The Disk tab view provides disk performance information. You'll see how fast data is read and written for each application and as a total, and you'll also know the amount of data transferred per second. The Network tab displays the number of data packets sent and received individually and in total. You'll also see total data sent and received measured in megabytes based on the amount of data transferred per second. And what if you need system diagnostics? Select the drop-down arrow where you can run a spin dump. A spin dump report helps troubleshoot why programs are crashing. You can also run a systems diagnostic test for hardware issues, and you can run a Spotlight diagnostics report to focus on evaluating system processes. In this video, you learned that you can click the wireless icon to locate and configure login information for new networks. You can view the computer name by selecting System Preferences, System Report, and then the Network Overview. And selecting System Preferences and then selecting Network displays the computer's name, IP address, related networking information, and the computer's MAC address. You also learned, within System Preferences, System Report, you can view hardware, network, and software overview details. Press the Command key and spacebar to open the Spotlight. Using the Spotlight, you can type Activity Monitor and click the icon to open the app. Activity Monitor provides you with performance information organized by CPU, memory, energy, disk, and network. And finally, a spin dump report helps troubleshoot why programs are crashing. Welcome to Chrome OS Operating System Essentials. After watching this video, you will be able to explain the pros and cons of Chromebooks, describe Chromebook setup essentials, describe parts of the Chromebook desktop, explain how to adjust frequently modified settings, and describe how to locate essential operating system and hardware information. Chromebooks, known for being lightweight and portable, are suitable for web-based work and storage and run Android apps available on the Google Play Store. Chromebook hardware typically includes less powerful processors, less RAM, and less local storage than standard computers. With reduced hardware needs, Chromebooks are generally more affordable than laptops and desktops running other operating systems. Chromebooks tend to be popular with students and web-based workers in small to medium-sized businesses. Around 2020, Chromebooks incorporated additional capabilities. Chromebook users could now mirror programs from their desktops and laptops and run mobile Android versions of Microsoft Office 365 products. So why doesn't everyone use a Chromebook? Chromebooks require an internet connection for access to web-based apps and functions. Google Apps and some other apps are available for offline or asynchronous work. However, many business apps and tasks require a network and internet connectivity. Chromebooks also offer a strict automatic expiration date. After that date, the operating system is no longer guaranteed to work with hardware. So, after you press the Start or Power button, you'll select your preferred language and click Let's Go. Next, join a Wi-Fi network. You'll enter the network name, specify the security type, and enter the network's password. You can also allow others to use the Chromebook to access the same network. Then sign in with an existing Google account or create a new Google account. Next, let's learn about setting up Google Assistant. You'll be prompted to enable Google Assistant. Google Assistant integrates with Google devices, including lights, music, and other devices configured in Google Home. You can use both voice and keyboard input capabilities to ask Google questions or ask Google to perform tasks, and you can adjust these settings at any time. You can also find Google Assistant using the Settings pane. Select Search and Assistant, and Google Assistant settings appear. Click the toggle to enable Google Assistant. You can also click the OK Google toggle to use Google Assistant with your voice. If you want to use your voice instead of the keyboard, click the preferred input toggle. To talk with your assistant, say OK Google and ask your question. Also, on your keyboard, you can press the Search key or the Assistant key. Next, let's learn about another Chromebook essential: how you can configure your Chromebook to use a preferred wireless network. In the Settings pane, select Network. In the Network section, click to toggle Wi-Fi. To automatically connect or reconnect to a specific network, click the Automatically Connect to this network toggle. To set the connected network as the preferred network, click the Prefer this network toggle. Now it's time to learn about installing apps. To install additional apps, use the shelf and select the Google Play Store app. You'll find apps for gaming, productivity, navigation, shopping, social sites, education, movies, and books. But after your apps are installed, how do you find them? Let's check out the desktop, the shelf, and the launcher. The desktop is your workspace. You can access programs and shortcuts using the shelf, and you'll use the open space to view open programs. You can also select the launcher to find and open programs. When viewing an app in the launcher, you can right-click an app to pin or anchor the app to the shelf. The desktop is also where you access frequently adjusted settings, such as speaker volume and screen brightness, locate the Settings app, and, although not enabled here, view notifications. When connected to the internet, Chromebooks can automatically check for, download, and install operating system updates. And within Settings and About Chrome OS, you can manually check for updates. You'll also be able to see which version of the Chrome operating system your Chromebook is running. After downloading the update, Chrome OS prompts you to select Restart to finish the update process. Chromebooks have a date when they will no longer receive Chrome OS updates. View update schedule details to see the expiration date. Some Chromebooks may also have a device name, but a search of this Chromebook device did not supply a name. To monitor your system performance, click Settings, then About Chrome OS, and select Diagnostics. Select System to view the battery health and a CPU usage graph. Scroll the System view to see more CPU details, and then view memory usage details. Next, select Connectivity, where you can view network performance. In this video, you learned that you need a Google account to use a Chromebook. Google Assistant, with both voice and keyboard command capabilities and notifications, provides functionality that integrates additional Google capabilities. You can use the launcher to locate files, and within Settings, select About Chrome OS to update the Chromebook operating system. You'll use the Google Play Store app to download apps, And within About Chrome OS, you can check the operating system update status, find the Chromebook's expiration date, and view system diagnostic information. Welcome to Introduction to Mobile Devices, iOS. After watching this video, you will be able to explain why companies support iOS devices, describe iOS setup essentials, including Siri, Apple's assistant, identify iOS screen types and navigation, explain how to adjust frequently modified settings, and describe how to locate essential operating system and hardware information. Apple, who owns iOS, provides a track record of security, extensive data privacy practices, interoperability with Apple desktops, laptops, and tablets, user satisfaction with the operating system, extensive app availability, extended employee availability, and corporate device controls. So, before you begin setting up an iOS device, plan ahead and have the following items ready: Wi-Fi access, the SIM card if needed, the existing Apple ID if available, a debit or credit card, and the prior device if migrating apps and data. After you press the Start or Power button, you'll choose the language and click Let's Go. Select your location and then connect to a Wi-Fi network. Accept the data privacy agreement and then set up security such as facial recognition, a password, or a PIN, and select whether to migrate apps and data. Next, you'll sign in with an existing Apple ID and password or create a new account. Then, set up iCloud storage, the keychain, and accept Apple's terms and conditions. Next, decide whether to set up Apple's assistant, Siri, and whether to share app analytics. Then, you'll configure screen display options to reduce blue screens at night. And finally, choose a standard or zoomed screen view. Now, let's check out the iOS device screens on an iPhone. With your iPhone set up, swipe up and display the home screen. Swipe right to display the leftmost screen, known as the Today view. Then swipe left until you see the final screen showing the app library. Whenever you see an app, such as the Calendar app, shown here on the home screen, you can tap to launch the app. By default, the Settings app is located on the home screen, and with more than 50 categories, the Settings app is the central location for customizing your iOS device. You'll also find additional application-specific settings for App Store installed items. Now, when you're ready to activate cellular service, within Settings, tap Cellular. On the Add Cellular Plan screen, scan the QR code provided by your carrier or type Enter details manually to type the setup information provided by the carrier. Tap Next to continue the setup process. To adjust how you see notifications, within Settings, tap Notifications and choose whether you will see notifications on a schedule, see notification previews, and see notifications when screen sharing. Also, decide which apps can suggest shortcuts when the screen is locked. For iOS devices, you'll get apps from Apple's App Store. By default, you'll usually see the App Store displayed on the home screen. Tap the App Store to view available apps by category or search for a specific app. And when you locate your app, tap Get to download and install the app. Connecting to Wi-Fi networks usually saves on mobile network charges and could be workplace policy. Within Settings, tap Wi-Fi. View the available networks and tap the network name, or tap Other to enter network details and connect to a network that's not visible. Next on the Enter Password screen, enter the password in its field and tap Next or Join as displayed. Siri, Apple's digital assistant, works with voice and keyboard input. Siri is compatible with Apple HomeKit and integrates with other iOS and macOS devices. You can adjust Siri's settings at any time. To use Siri, you can say, "Hey Siri," or you can press and hold the button on the right side of the phone to speak your request to Siri. Accessibility is built into iOS, with currently more than 20 accessibility categories and the ability to add apps and customize per app or individual app settings. Users frequently customize the on-screen display and brightness. Within display and brightness, you can adjust the screen display from light to dark, change the light tone from blue to yellow, schedule display changes, change the text size, and more. Let's now check out important device information you'll need to know. Within Settings, tap General and then tap About. You first see the device name, which you can edit. Then you'll see the current iOS operating system, device model name, device model number, and the device's serial number. Scroll to view the system storage capacity and available storage capacity. Then you can see the device's current Wi-Fi address, Bluetooth address, and modern firmware version. The SE ID is the Secure Element Identifier, a near-frequency communication chip. Next is the EID, which is the acronym for the electronic SIM card, but not all iPhones have an electronic SIM card. Scroll again to find out if the device is locked to a specific cellular carrier. Then see who the current cellular carrier is and view the following identifiers. First is the IMEI, a unique 15-digit number assigned to every cellular device. IMEI numbers are internationally registered. Next is the ICCID, the identifier associated with the SIM card. And the MEID is a 14-digit PIN code assigned specifically to mobile devices. For example, an IoT device might have an IMEI, such as an electric meter, but since it's not a mobile device, the meter won't have an MEID. And finally, some phones may have a second IMEI 2 slot. This second IMEI enables iPhone users to keep one cellular plan for business and a separate personal plan on the same phone, or use a local carrier when traveling internationally. You can set iOS to automatically check for, download, and install operating system updates. Within Settings, tap General and Software Update. Set automatic updates to On. When Apple releases a new iOS version, you'll see a message providing you the opportunity to upgrade. In this video, you learned that organizations appreciate Apple's security, data privacy practices, and seamless interoperability with other iOS and Mac devices. The Settings app is where you can adjust iOS settings and check storage and performance-related information. The three main iOS device screen names are the Home Screen, the Today View, and the App Library. Siri, Apple's digital assistant, works with both voice and keyboard input. And the About settings page provides device, communication, and cellular identifying information. Welcome to Introduction to Mobile Devices, Android. After watching this video, you will be able to describe why organizations support Android devices, describe Android setup essentials, including Google Assistant, Google's digital assistant, identify Android screen types and navigation, explain how to adjust frequently modified settings, and describe how to locate essential operating system and hardware information. Android currently holds a global market share of 77%. Android is an open-source operating system supported by Google. Android supports development by multiple vendors, providing opportunities for innovation and multiple price points for devices that help extend employee availability and provides corporate programs with device controls. So, before you begin setting up an Android device, you'll want to have the following items ready: Wi-Fi access, the new SIM card if needed, the Google account ID and password if existing, payment options for the Google Play Store, and the prior device if migrating apps and data. With Android devices, setup processes will likely vary based on the device manufacturer. Connect your phone or device to a power source. After you press the Start or Power button, you'll choose your language and install your SIM card if needed. Then connect to Wi-Fi. You'll then sign into the device using your existing Google account or create a new account. Next, set the device date and time. Set up security, such as a PIN, drawing, passcode, fingerprint, or facial recognition. Then begin downloading apps and data. Now let's check out some Android phone screens. If you set up your phone's security, the lock screen displays when you first power it on. After you enter your security information on the lock screen, you'll see the first home screen. Whenever you see an app, such as Google One Storage app, shown here on one of the home screens, you can tap to launch the app. Next, let's view the Settings app. The Settings app is your central location for customizing your Android device. You can find the Settings app on one of your home screens or by searching for the app and typing in the predictive text SET. Now tap the Settings app icon. Organized into about 20 categories, you can use the Settings app to manage network and internet settings, view battery life, check your device's storage capacity, update the display, configure accessibility and security options, configure application-specific settings, and much more. So when you're ready to activate cellular service, within Settings, tap SIMs. If your device is capable of an eSIM, you can download your eSIM or digital SIM card number from your cellular provider, referred to here as your network or network provider. Confirm your network. Now, with your provider confirmed, scan the QR code provided by your carrier and complete the setup process. Next, tap the top of the home screen and swipe down to view notifications. To adjust how notifications are experienced, within Settings, search for Notifications. Here you can see some of the notification settings, such as configuring notifications based on the app, viewing notification history, how conversation notifications are seen, and numerous other settings. For Android devices, you'll obtain apps from the Google Play Store. When you tap the Google Play Store, you will see suggested apps, available apps by category, and you can search for a specific app. When you locate your app, such as the IBM security software shown here, tap Install to download and use the app. Next, let's learn about connecting to Wi-Fi networks. Within Settings, tap Wi-Fi. View the available networks and tap the network name or tap Add Network to enter network details and connect to a network that's not visible. For the new network you selected, enter the password and tap the checkmark icon. Now, Google Assistant, Google's digital assistant, works with both voice and keyboard input. Google Assistant, compatible with Google Home, also works with an ecosystem of other Android-compatible devices. You can adjust Google Assistant settings as needed. To use Google Assistant, you can say, "Hey Google," or you can press and hold the button located on the right of the phone. You can then speak your request to Google Assistant and you'll see or hear a response. You can customize Google Assistant to ask questions, control devices, plan events, and more. Within Settings and Accessibility, you can activate an accessibility menu, adjust accessibility shortcuts, update visual settings, and configure the time you have to respond to apps. Users frequently customize display settings. Tap Settings and type Display. Tap Display Size and Text, and on this screen you can adjust the size of icons, the text size, and set text to bold and high contrast. Now let's check out important device information you need to know. Within Settings, tap General and then type About and view About Phone. You can view the device name and model number, and you can also view the IMEI, a unique 15-digit number assigned to every cellular device. IMEI numbers are internationally registered. This device has one physical SIM card slot and a second eSIM slot. A second SIM card slot is often used for travel or when using a phone both personally and professionally. Next, you can see the device's current IP address, Wi-Fi MAC address, and Bluetooth address. Also, selecting About Phone displays important information about the operating system, including its baseband version, kernel version, and build number. This information is helpful for troubleshooting operating system issues should they happen. Android usually provides monthly operating system security updates. Each device manufacturer pushes updates to its branded devices. Android device owners receive a notification that an update is available and can choose to install the updates immediately or later. If the device is corporate managed, the administrator can choose when to push operating system updates to their devices. Here is how to check if your version of Android is current. Within Settings, type System and then tap System Updates. Then tap System Update. You'll also see the Android version your device is running and when the system most recently checked for updates. Note that you can also manually check for updates at any time. In this video, you learned that organizations appreciate Android's security, data privacy practices, and seamless interoperability with an open ecosystem of providers and devices. The Settings app is where you can adjust Android settings, configure cellular service, view essential device information, and update the operating system. You can manually check for Android security updates at any time. And Android device owners receive a notification that an update is available and can choose to install the updates immediately or later.